Hi, team. Very good evening and good morning, all. So let's get started, guys. Okay. First of all, thanks for joining in this the out of our session time. The reason behind, I don't wanted to maybe like take this database session, which is an additional session, which is a kind of an what to say, a complementary or a supplementary session that is needed for all of us to learn, right? Before we go into the core data engineering learning with the help of the SQL and the database kind of query activities and all that we are going to perform. So this learning, what you are going to achieve out of it, right, is very important to understand. And who are all going to achieve what is also very important to understand. And the database learning is going to play how much role in our entire growth or entire career journey. I'm going to explain all this. We are going to get some understanding right now, primarily. Okay. So I'll tell you the agenda. Maybe I'll take you guys to the agenda of what you're going to learn, because I know there are a lot of confusion in this particular database additional learning alone. Okay. Um, and I'll be helping you resolving all those questions primarily before we go into the actual part of the learning. Okay. And what level of learning we are going to do, who are all going to be get benefited out of it, and why we need this learning, everything I'll just help you guys understand. But before going into it, first of all, I'm thanking you guys once again for joining by this time. Especially, I'm intending this learning or this teaching particularly for the our aspirants who are all not from the SQL background either, and who are all maybe like having some basic idea about SQL, or who are all did not have any idea about what is SQL or a database means, and who are all having some idea, some SQL knowledge and experience even, but they wanted to get this learning more better, or the people who is already expert in SQL, they wanted to connect along with me to maybe get one more round of the understanding from in the way like how we are going to learn. Like this, it could be applicable for everyone. But very importantly, if you say like I am not in a position to understand like what is a database, or I don't know what is a database, difference between database and the file system, like this and all, if you say, this session is going to help you a lot, guys. Okay, so definitely there are two things I would say, team, it is my responsibility to give you all this. Okay, and very importantly, I wanted to convey one thing to you. So far I did not engage this database session in my so far 10 years of time period. I used to bring somebody, maybe like at this time particularly, right? Particularly, rather than conducting this session additionally, right? I will take some time. I'll take some off time for myself, and I will not engage this session. Rather, I'll bring somebody who is having some SQL or database knowledge to convey this. But what I would felt, like after some time of doing that, I realized one thing. Whatever I wanted you guys to be get imparted for making you learn the big data, data engineering, Spark or cloud related SQL activities, and whatever we are going to do, right? That requires some particular knowledge of understanding the things. So what I do, I take it in the regular session basically. The same fundamental things I used to talk in the regular session also. To avoid that, right, what I'm doing, I itself wanted to take this session to all of you. So by that way, we are getting connected today. Okay, guys, these are all some ground things what I wanted to bring before we go into the actual part of the learning. So as such, this topic or this slide have the front page, right? Particularly like what I did, I yesterday sent you a wrong version of the slide, which we use for some older batches and all. If you see here, right, this is the old slides what we used to use. But I made a complete change on this slide, right? If you see here, yesterday night, I even worked on this slide to make some changes. This is the old slide what I initially sent to you wrongly. Okay, this is the slide what we use to just discuss with you guys and all. And this is not discussed by myself. This is discussed by some of the other maybe like the trainer who have taken the database session earlier. I revamped that slide to give you guys a lot of other input, other learning content also in this slide itself, other than the SQL. SQL I'm going to give you guys separately. But I have given a lot of learning contents in this slide. You can make use of this very efficiently for learning. Okay, you wait for it. I'm going to tell that like what are the learning contents you got in this slide. How do you make use of it and all? Like the mind map, or whatever the grammar, the SQL grammar, or whatever I'm just giving you. I help you guys understand how you have to understand, how you have to recall SQL, how you have to learn SQL efficiently or smartly. That also I'm going to convey to you. And somebody were asking, even in the group, like, Irfan, is this the only session, or we are going to have sequence of session on this? We are going to have two sessions on this. Okay, one is we are going to initially learn the fundamentals, foundation. I'm going to convey something to you guys. I'm going to introduce the database, tables, or RDBMS, and these things and all I'm going to introduce with you right now. And I'm going to do some practice of SQL queries, and I'm going to make you guys parallelly set up the environment and practice along with me also, right? That initiative I'm going to take right now today. And we'll have one more session like this also in a later point of time to cover some nitty-gritty things, some nitty-gritty SQL things and all. I wanted you guys also to practice along with me, especially the people from the non-SQL background. I wanted to get benefit out of it. Definitely, they should not say, "Hey, Irfan, I don't know what is database, how to work and all." To make that base understanding very strong, I'm not going to directly enter into the database tables creation, modification, and everything. I'm going to take some sample thing what we are already aware of. Okay, everybody might have used this tool. I'm going to use that tool first of all to make you guys realize what you are going to learn overall in our entire. If you say I am a SQL developer, I am a database developer, if you wanted to say what you are supposed to know altogether, I'll first cover that in a layman perspective. Then we go and start write the SQL queries and all these other types of learning and all. And I wanted you guys to be parallelly work with me to do that. In the subsequent session, one more session I'm planning to conduct. Okay. Let us have that agenda and all set. I'll just set with you guys, wait for a while. So as such, this overall presentation I named in such a way, database fundamentals and foundation we are going to learn. We are not going to learn anything explicitly, anything advanced and all we are not going to learn. The advanced part and all, the next level, maybe the low level to mid level we are going to learn right now. In the today's session and in one more subsequent session, like this, we are going to learn the foundations and fundamentals and some mid variant of the database concepts we are going to learn. The tables, queries, and all these concepts we are going to learn. That is the plan altogether. And the advanced level, maybe the comprehensive database learning or comprehensive SQL learning that we are going to do in our regular part of the learning. Basically, I would say this is like the introduction that I'm giving to you. This is how we have to work in database, guys. When we go and learn the same database concepts, SQL concepts, and everything, when we implement it in our big data engineering platform, in the name of Hive, in the name of Scoop, in the name of Spark, in the name of BigQuery, in the name of Synapse, or in the name of Athena, or maybe like in the name of Databricks SQL, or in the name of what to say, like Cloud SQL, Cloud Spanner. In any of the name, we are going to learn the same database only in different perspective to become experts in database, experts in SQL. They're going to become expert in structured query language along with semi-structured query language. SQL also we are going to learn. P-SQL also we are going to learn. Programming, structured query language also we are going to learn. Function-based programming, SQL also we are going to learn. So we are going to develop our SQL will be included in every part of our learning going forward. Right? So we are going to, after we complete the yarn and map reduce right now what we are learning, once we complete this part in by tomorrow, mostly for the weekend, and by Monday or Tuesday to the weekday, once I complete that part, we are going to more fully enter into the SQL platform only. Okay. So this is like a foundational session for that. You should not ask me one question when I'm taking you guys to Hive, when I'm taking you guys to Spark SQL. You should not ask me one question. Irfan, what is a table? What is a row? What is a column? What is a data type? How to write a query to filter the column? How to write a query to filter a row? This SQL query writing, what I'm doing is coming under the category of DML or BQL or TCL or DCL or maybe DDL. Like this, you should not have any doubt or any confusion in that. This foundation will help you understand the entire part of what you're supposed to know in SQL fundamentally, foundationally. Okay, this is a foundational session. I'm going to be with you guys for conveying it in a very simple perspective. Okay. What is the memorandum of our understanding? What is the context that we are setting in the understanding of our SQL learning? Basically, if you ask me a question of all this, right, Irfan, how much SQL learning is important? The SQL learning is important in such a way, right? It is like a mother tongue of every IT people or every people who is working in organizations, be it IT or non-IT, even you consider. You are going to play a role of a core developer, a fresher. Fresher, you are going to enter into an organization, or you are a front-end application developer. You are a tester, or you are a manager, or you are a lead, or you are a project lead, or you are a senior manager, you are a director, you are a senior director, you are a VP, you are a client, you are a business associate, be it anyone. SQL is like a foundation for it. SQL is like a language for you to communicate with the system in the name of the server, in the name of the DB server or data warehouse server, or a file server, or a big data server, or a big data cluster, anything you name it, the cloud native cluster, or on-prem cluster, or any system you name it, if you have to communicate with that system efficiently to understand about the data of your organization, the data of your competitor, the data of your employees, the data of your products, the data of your customers, and everything. If you want to understand efficiently to survive in this world, how much the mother tongue is needed for us, that much is needed for us being in IT. You play any role in IT. You play a technical role or a non-technical role in IT. The SQL plays a vital role for everyone. SQL is becoming like an English language. Whoever knows how to speak in English, how to write English, they can write SQL queries without any hassle. Directly, they can go and implement their SQL knowledge to learn SQL. English knowledge to learn SQL. Okay, so SQL is like a mother tongue for everyone, and everybody who were in IT or non-IT who is going to understand about the organizational data, the system data, the customer data, and everything, they can use SQL either by writing as a SQL query, or either they can apply the SQL functionality, the SQL kind of conceptual knowledge they can apply even in an Excel sheet, even in a G sheet, or even in a PowerPoint. Everywhere they can apply the concept of the SQL altogether. So SQL is that much important. Without knowing SQL, we can't call ourselves as I am a person working in IT. Okay, that much important it is primarily. How much it is important for our learning? Whatever we are going to learn for another 6 months or 7 months of time, right? Overall, 9.5 months of time we are going to spend in this entire learning. The another 6 months of time we are going to mostly spend in usage of the SQL learning, not today's learning. I'm telling you, we are going to slowly evolve on the SQL only, applying it in multiple places in multiple tool names. Multiple tool names we are going to apply, but everywhere we are going to impact the tool with SQL only. Even the scoop, just we tried importing the data from a database, we used a SQL kind of queries only, where or maybe like columns, right? Like this and all we were using. Even we can write a free form SQL, a normal select star from table name, group by, or having, or everything we can write in that. Scoop even, because Scoop even uses SQL. Hive uses SQL. Every tools what you are going to learn, mostly we will see how to make use of the SQL to be aligned with the tool. The tool will say, Irfan, you write SQL query, I'll make use of that SQL to convert it in any other language in the background. That is a different story. But every tools are going to be driven based on the SQL. If I talk about PySpark, you are going to use Python programming language to control the SQL execution everywhere, right? In the cloud component or in the on-prem component, we are going to use SQL very heavily. So SQL is very, very important for everyone, including data engineers. Okay, that is the first point. Second one, what and how much SQL we are going to learn in this session. As I told you guys, we are going to learn particularly about the grammars of SQL. Okay, we are going to learn about how we can have a mind map created like this. If you see this beautiful, whatever the GIF image, right? This GIF image shows, if you know about all these concepts, not all these concepts, if you know all these concepts, then you can say You are a SQL developer, then you are a database developer. But for a data engineer, right, for a data engineer, for a SQL developer, not for an administrator, you're not going to play an administrator role. So some of these components have some administration feature also. Let's forget about the administration feature. You are going to become a SQL writer, SQL developer, or a SQL analyst, data analyst, or a data engineer. Like for these kind of activities and all to perform, we have to know out of this entire grammar, right? Importantly, certain things, and to an understanding purpose, certain things. This entire grammar, if you understand whatever is highlighted, whatever is going in a beautiful GIF image, if you understand that, or if you know how to work on that, and what is what, if you understand, then you can say the content what you are going to learn is more related to what I'm showing you in front of the screen, which is showing some highlighted things. Like SQL means what we are going to understand. First of all, why the name SQL has come. Subsequently, what is DCL, what is DML, DDL, TCL, DCL, DDL. Like this, we are going to understand certain jargons of it. And inside the jargon, what and all we can do, we are going to understand. If you know about all those, then you can say, I am a SQL developer. I know how to work in SQL, how to write maybe like comparison operator, how to write logical operator. Like this and all, you are going to talk in that kind of terminology slowly. It will take some slow time after you get practiced on everything. After I cover, you'll get a very big clarity, very better clarity of writing SQL queries. Okay, we are going to do that. Then subsequently, who are all the intended learners? For this particular session, the intended learners are, I told you guys already, right? Who are not having any ideas about SQL. If you say, I did not even try writing a select star from table name in a database so far in my lifetime, you are going to get benefited. I know some basics of SQL, but not in a formal way. Or I know advanced SQL, but I wanted to get one more time the learning of this in a bit proper approach like this. Anything you can say. Or you can say, I am not into this world of SQL. I'm more fully into data analysis, or I'm more fully into data administration. But I wanted to learn more of data engineering. I wanted to do more of SQL querying. Like this, if you say, you are all the intended learners, or everybody are the intended learners of this, I could say like that. Then finally, how to learn SQL smartly. Very important point to add. We can learn any tools, but how to learn the tool by putting a hard effort than smart effort. I'll cover that smart effort also subsequently with you guys. If you understand the core behind any tool, working on the tool smartly is very easy. For example, I would say you have to create a mind map first of all. Then you have to understand the grammars of that mind map. Then you have to understand very importantly the syntax and semantics. Two parts we had to learn: syntax, semantics. If you know about these components in SQL is a very simple language to learn. SQL can be learned by everyone very easily, without any hassle, without any effort that you put. Effortlessly, you can learn. So we are going to put some smart effort to not learn SQL, to implement SQL more efficiently as well. So that is what the learning we are going to further execute, and how we can practice on this environment is fun. Where is the practicing environment for me to practice? Are we going to, are you alone going to write some SQL query? I'm also going to write. I'm going to first write some SQL queries to make you understand all this context, all these grammars and the mind map components and all. Then I'll be asking you guys to try out as well. Maybe that is what I'm planning to do in one more session. I want to give some time for you guys to execute all the SQL queries along with me. Or I will be sitting idle and listening to you. I'll helping you guys to understand the SQL queries by having an hour or 1.5 hours of session to make you guys fully get a grip on the SQL queries. Okay, that is the plan I'm having for a subsequent session, where I will be asking you to work along with me on the SQL queries to get practice, and offline practice also I wanted to do by you guys by having the SQL environment set. Okay, with that said, let us go inside our part of learning. But before going into it, right, I would like to understand, looking into this, right, looking into this image, whatever this GIF image, how many of you know or don't know about what is SQL? The term what is SQL itself, I don't know the expansion of SQL is fun. Like this, how many of you are there? Maybe you can raise your hand either, or you can say, I am in. I mean, like it is a learning, guys. We are all being here to learn. I wanted to understand, to give you a better teaching, right? What is the SQL means? I don't know if one, what is the SQL? The expansion of the SQL, I don't know. Anybody is there like that? Not even one person is there like that. I would say like there is a chance. Not even a one person say, Irfan, I don't know what is SQL. I know what is SQL. I heard from either you or at least by some way here and there. I heard at least what is SQL. Okay, fine. Lalita Priya. Okay. So Lavanya, right? What is SQL? SQL means what? Now the people who were already have an idea about what is SQL, some idea about what is SQL. Guys, tell me what is SQL? SQL means the English of it, the English term of it, structured queried language. Structured query language. As what most of you guys are telling. Correct. 100% correct. Structured query language. What does it mean? Why they are naming it like that? Why did they name it like that? We have to understand. Everything is in English, I told. If you know English, you can able to interpret what is the SQL, RDBMS, database. Everything are similar. SQL is a language used to interact with a database, which is having a model of RDBMS, relational database model, relational database management system, RDBMS. So people used to call SQL, RDBMS, database, everything as same. But actually, RDBMS, database, SQL, all are three are different components, but all work in tandem. How we can relate all of them? We write a SQL query on top of a database by using the relational database management system concepts. So I would say like we use this three terminology to describe our learning. We are going to learn all the three. All the three we are going to learn. What we are going to learn all the three is, we are going to learn what is RDBMS, what is RDBMS, what is SQL, what is database. All the three you can interchangeably use. You can use this term interchangeably. Okay, you know, I'm learning a database today. You can say like that. Or you can say I'm learning SQL queries or SQL today. Or I'm learning RDBMS today. Anything you can name. But all the three are bit different components. How can I differentiate? Database is an environment where the data will be kept in a form of schemas, databases, tables, views, indexes with rows and columns format. Database is an environment where we have the data stored. In a model of relational database management system model, the model implemented on top of the database is nothing but relational database management system. The data is interrelated and kept. The tables are available, which will be ready for connectivity, ready for connected analysis, connected storage or retrieval of data. The structured query language, SQL, right? The structured query language, as I told, it is like an English language we speak. If you know English, you can learn the structured query language efficiently. So the structured query language used this RDBMS model to read or write the data from a database. So if you ask somebody, hey, what is the difference between database, RDBMS and SQL? What everyone say, all are same almost. I'm not finding any difference between them, but the difference is there. Okay, SQL is SQL, RDBMS is RDBMS, database is database. I hope you got some high level idea of what is the difference between these three. We are going to learn, we are going to understand that and all subsequently. How we are going to understand? We are going to maybe like read or we are going to connect to a database by setting up our environment to connect with the remote database. And we are going to create some tables and we are going to connect those tables with the help of joins, unions, and all these kind of operations and all we are going to perform. subqueries, joins, and all this we are going to perform. By the way, you will understand RDBMS model means what. You write queries, any query that you write in a database, either by applying RDBMS or directly you are fetching the data from the, DB, from the database by writing queries. Anything you can achieve, right? So the SQL query we are going to learn altogether. Finally, we are going to land up in learning what you know, spending our time in how to write a structured query language to perform data processing and data analysis, especially the structured query language will help you perform data processing and data analysis, data manipulation and data query. It is going to help us achieve. We are going to learn that part only majorly by spending our time. There are some nitty-gritty components are there, but we are not going to learn everything. Okay, I'll come back to that part, guys. So DB, RDBMS, SQL, all you can say same relatively, but it is different. It is not literally same. Okay, fine. Structured query language, what does it represent? You have the data in a structured format. What is SQL? What is the expansion of SQL? You guys all told. Yes, Irfan, I know. Very few of you say, no, Irfan, I don't know what is the expansion of SQL. Fine. Now you got an idea. Expansion of SQL is structured query language. That represents what? You have the data in a structured format. I am going to use a language. I'm going to practice on a language. I'm going to learn a language to query, to get some output or outcome out of that structured data that is present in a database. I'm going to write a query using a language that I'm going to learn to bring the data from a structured store. That is called structured query language. The database holds the data in the form of tables. The table is structured. The table contains some defined number of columns, some defined data types of the columns. That is called structured. I am going to use a language in the name of SQL. I'm going to use an SQL language to query the data from the table. That is called structured query language. Following me, team, what I'm speaking. SQL is used to query the data from a database table where the table is in a structured form. I'm going to write a query to pull the data, push the data, modify the data, delete the data, remove the table itself, remove the database itself, create a database itself, create a table itself, anything I can do in and out. That is the purpose of structured query language. The SQL is propagated in different perspective. There are different types of SQLs available. That is the very important part of our learning. That is where we are going to make our fulcrum. We are going to have a reference point of starting with what? We are going to learn SQL. The SQL is of different types. How many of you knows about what is DCL? The expansion of DCL. Just what is the expansion of DCL? How many of you know? Raise your hand, please. Okay. Couple of you guys know about what is DCL. I would say, if I ask how many of you know SQL, most of you guys say, I know SQL. I know what is SQL, structured query language means. But I don't know what is DCL. What is DCL? Very minimal of our people says, yes, I know what is DCL. They are definitely, I would say, those people are definitely have some grip on working in databases, working in SQL queries. But how many of you know how to write DCL? If I ask, I know how to write DCL, Irfan. Right away, if you ask me to give some access to a table in a database for a given user, I know how to write. How many of you will say, I know, Irfan, how to write? Other than DBS, other than database administrators, right? If you are a SQL developer, if you are a data analyst, if you are a data engineer even, if you are a SQL developer even, you will say, no, Irfan, I don't remember that syntax and all. Agree or not, team? Anybody over here say, yes, Irfan, I know how to write the DCL syntax. I know how to write DCL. I know what is DCL means. How to write DCL? Anybody is being here to say, yes, Irfan, I know? I would say hardly. Most of you say no, including myself. Even I am not much familiar in writing DCL because I am not a DBA. Clear, team, what I'm speaking? But what is DCL? Again, I told everything is English. In SQL, everything is English. That is a smart learning. Like I'm telling how to learn SQL smartly, right? Don't see SQL like a different language. It's a Latin language. Don't see it as a Latin language. It's not a Greek language. It's not a Latin language. It's an English language. If you say I know English, then you can say what is DCL means. DCL means what you can say. This is not DCL. This is TCL. There is a mistake here. Okay, keep it aside. I'll talk about it. DCL means what? Data control language. Data control language. What is the name itself says? What is the English word itself says? Say the data can be controlled by using some queries, by writing some syntax, by writing some English words. You can control the access given for the users to a given data set, to a database, to a table, or to the objects of the database. You can control the access given to the database tables or databases by using this data control language. Like this you can say. That is DCL. DCL means what? We know. DCL's expansion is what? DCL means what? We know. But how to write DCL queries? We have a very less understanding because DCL is not regularly used methodology of SQL. It's not a SQL type regularly used. There are different SQL types are available. One is DDL, right? Another one is DML. Another one is DQL. Another one is DCL, TCL. Anything I missed? These 5 are the SQL types. Overall, what are all the SQL types that we have in a database or in any databases you consider? You consider Oracle or SQL Server or Teradata, MySQL, DynamoDB, not DynamoDB, Postgres or DB2 or any database you consider. These 5 are the types of SQL we write. One is DDL, DML, DQL, DCL, TCL. The unfamiliar items are DCL. DCL is very rarely used, mostly by the administrators of the database. Then second one, which is not familiar, is TCL. What is TCL, guys? How many of you know about the expansion of TCL? TCL's expansion, how many people know? Transaction control language, again an English. Transaction control language. You go to a shop, right? Basically, the entire thing can be categorized into our regular purchase pattern. What we are doing, you are going to a shop, a supermarket, and buying some product. Okay, you can relate with that one entirely with all these kind of SQL queries. So you are going to a shop, you are allowed inside a shop or not, that will be decided by what? That will be decided by the data control language. The control of the data will be taken by somebody to allow you or not. Whether I can restrict or I can allow somebody to access this. Whether I can give or grant access to somebody, or I have to revoke the access of somebody to perform something on some other item. Like this, we can have a data control language to control the access given to the data. Transaction control language says what? Which is also unfamiliar, not much people use this, but still. Transaction control language says what? I'm going to control the transactions that is going to happen. You purchase the product in a shop, but you are going to return it back. You are telling, hey, revert the transaction. I just paid some amount to you, right? Refund it back to me. I don't want to complete this transaction because of some reason. I'm going to a shop and buying, I'm looking for 10 items to buy, but I'm finding only 9 items. One item is not present in that shop. So I'm telling what, hey, I don't wanted all the 10 items. I'm not getting all the 10 items. So let me revert all the 9 items back. Let me keep all the 9 items back to the tray. I'm not purchasing anything. If I get all the 10 items, then only I can go and cook this food at my home with all these raw materials. If one item is missing, salt is missing, then there is no meaning of cooking the food with the balance 9 items. So I'm reverting it back. That is nothing but the transaction control language. How many of you know how to use the transaction control language? To a basic extent, if I ask, they'll say, yes, Irfan, I know. What is commit, what is rollback, I know. What is save point? What is rollback to save point? How to make use of this transaction control efficiently? They'll say, Irfan, I did not use much of that. Especially the data engineers will say, I'm not using transaction control language at all. But the database core developers will say, yes, Irfan, I'm using transaction control language in my databases and all. So transaction control language also, we will be having people very less having the familiarity of it. Agree or not, team? Can you say in your daily life, in your organization, working in SQL queries, we have a couple of our team members who is working, who is the SQL developers or who knows SQL, are attending the session right away. They're telling what is fun. I'm writing SQL queries for getting the data analyzed. Himanshu is telling like that. Himanshu is a person who is a data analyst. He's telling, I know how to write queries to analyze the data, but I don't know how to write queries to control the transaction and all, because I'm not sitting as a cashier in the bill counter. I'm working as a data or a data analyst to analyze the data. I am more fully aligned towards DQL. Data query language I'm more fully aligned towards. Like this, Himanshu will say. So the transaction control language is used in the databases. Please don't do the scribbling in my screen, guys. Please don't annotate, okay? Okay. So the transaction control language even is used very less. What is transaction control language? Wait for a while. I'll go and show you guys in a layman perspective. Then we have to understand about, see, these are all we can least bother in fact, but however we are going to learn about this in our learning, in our today's learning. In addition to that, we are going to learn about fundamentally, primarily, what is DDL. What is DDL, guys? DDL is, you know, most of you know, right? What is DDL? Data definition language, right? Most of you guys are telling, I know what is data definition language, including our data analyst. Everybody of you say, yes, Irfan, I know what is data definition language. I did some data definition language activities in my regular work, once or twice or thrice or sometime, once in a while, once in a month, once in 2 months. I did some DDL operations, very rarely, but not regularly, but I'm very much familiar in that. What is DDL? We have to know still, but I'm just giving a high level idea of DDL is couple of people or most of people are familiar in it. DDL means data definition language. We are going to define something related to our data in the DDL. We are going to create a database telling what, hey, let's create one database called credit card info. Let's create one database called insurance info. Let's create one database called core banking. Let's create one database called investment banking. So the database we are creating for holding our investment banking tables and all inside it. That is even a DDL. We are creating a table inside that database, defining a structure, customer table, customer ID, customer name, age, address. We are giving a definition for the data. That is data definition language. We are defining how the data has to be, how my data has to be. I'm going to create a table structure. That is even a DDL, right? So DDL is one of the important component, but the usage of that DDL is relatively less. DML. DML. Data, what language, guys? Most of you are familiar in this. Data manipulation language, where it is kept here. Here. Data manipulation language. I'm having this more better way mentioned in the subsequent slide and all, but let's have this data manipulation language. Data manipulation language. I'm going to do some manipulation on the data. I'm going to update something, insert some data, delete some data, merge some data. Basically, in the DML, we have something else called one more small branch of a category called DQL, data query language. People used to call the select statement also as a DML, but actually it is not a DML, it is a DQL. Under the DML, under the manipulation, we write select, but we don't affect that. We only do the query. We don't affect that data in the data set. In the table, we don't affect with the data, whatever I'm updating or deleting or inserting. I only do a query. So it comes under data query language, DQL, data query language. So I'm just giving you a fundamental of these are all the jargons what we use after SQL. If you say like I'm being here to learn SQL, the SQL comprised of these 5 types: DML, DQL, DCL, TCL, DDL. Like this, you are going to mention predominantly. This is what you have to first understand. What is database? What is RDBMS? What is SQL? All the 3 we can use. I'm learning that, but all the 3 are different. All the 3 are same, but different. Okay, let it be. And in this 3 category or in this terminology, the SQL terminology, we have some types, some categories of writing SQLs. So certain set of people will write DDLs, certain set of people will write DML, certain set of people will write DQLs, certain set of people only will write DCL and TCL. It varies based on what type of people are going to work in it. Very fundamentally, if I say the DDL will be returned mostly by or defined mostly by the data modelers. Data modelers will define the DDLs. Define the DDLs. Tell how the DDL has to be. But the data modelers will give these DDLs to the database administrators to really create the tables. DML will be done by the SQL developers, application developers, SQL developers, or application developers. I'm going to create an application, a front-end application I'm going to develop. In that application, I'm going to develop a form. Customers are going to book a product, book a ticket, book my show application I have. In the book my show application, I will use the DML operations very heavily. Customers are going and clicking a page to watch, to book a ticket in the movie. They'll choose all the seats. I'll go and put an entry in my table mentioning there is a ticket ID of so and so created, paid with this much amount, this many number of tickets they booked, this many number of seats they reserved. So these seats I should block in my table for the given show. I should not allow the same seats to be booked by somebody else. The people who is developing the application will be using this transaction control language also, the SQL developer who is working in the application development. If I'm going to develop a book my show kind of application, I'll go and recruit the front-end developer and the back-end developer. Back-end means database developer. Front-end means the web UI developer, including the person who is going to write a .NET or C# or maybe like what to say, like Node.js or AngularJS kind of applications they are going to write. Full stack developer. That full stack application developer will work with the database developer to understand, oh, what kind of transactions or what kind of DML we can perform here. If you are going to the book my show, you are adding some whatever the seats and you are not booking the ticket after 5 minutes, after 2 minutes. What they will do, they don't hold the ticket. They'll release the ticket for others to book. They'll say your session expired. How they expire your session? They will make your tickets hold for you first of all. If you are reserving some ticket at and then choosing the seats, it will not be displayed for others. Did you saw that in the book my show, guys? You could not able to go, others can't book the ticket at that time. It will be blocked. Even you did not close your application. You are opening in one more phone. You can't see that. That is because of they are using the transaction control language efficiently there. But what I'm telling, we don't have to worry on these and all because we are not a application developer. We are not going to work as a backend developer. If you are going as a SQL backend developer or an application developer, then those people will use this DML and TCL very heavily. We may use DML as a data engineer to an extent. One core rule we have in our big data engineering platform is what? A data we are going to collect, which is already happened. Whom you to change the data? You are not supposed to change the data. So we use the DML very minimally. Very minimally the DML will use, but we have to know how to work in DML. We do DML also, but DML usage is very less. What is DML? We are still yet to learn. Data manipulation. I'm going to change the data. I'm going to create the new data. I'm going to delete the existing data. Who will use what? The different things are being used by different people. That is what I'm trying to make you understand. The DQL will be used by whom? Everybody in this world will use DQL without any doubt. Everybody wanted to, administrator wanted to see what data, which users have logged in, how much data they created, everything they wanted to see. The data engineer has to know. The client has to know. Business user has to know. Data modeler has to know. Everybody will query the data from the table. So the DQL plays a vital role in our learning. This is a very important component you have to bother. All other 4 components, you don't have to worry too much on it. Take it very lightly. Data control language, mostly DBS only will be using. Like, there are different persona of people will be using this type of SQLs in their regular life. Mostly, being as a data engineer, being as a SQL developer, being as a data analyst, right? Or being as a SQL developer, anybody you mention, you are going to mostly use DML, DDL, and DQL. Out of which, the DQL plays a vital role. We are going to spend most of our time in writing DQLs. DQL means what? The select statement. We are going to work on the select statement only very heavily in our entire learning today. But before covering the top, before going to the DQL, which is our core part of the learning, which is our bread and butter of the learning, we are going to cover these other items and all as per the need. How much it is needed, we are going to cover these items and all respectively. Okay, this is the context, the memorandum of what you are going to learn overall days. I told how do you learn SQL smartly, right? If you know about what is DML, DDL, DQL, DCL, TCL, and who use what, how much we use, how much we have to know in this components, which components we have to know more. If you know about that, then you can learn the SQL more smartly. First smart way of learning. I'll subsequently take you guys, but first way of learning. Okay, let me move forward, guys. I'll talk more in detail about DDL, DML, DQL, DCL, and TCL in the down. I'm going to stop on each and every of this topic, and I'm going to take you guys to the box and show you guys how to work in it. Okay, let us move forward. This is going to be a kind of a image for you to understand. Oh, okay, the SQL has footprint on all these items. Out of all, we are not going to use everything. DQL means data query language. Data query language. Okay, Mohan, that is what we are going to mainly concentrate towards. How to query the data. That is DQL. Okay, some people you will use the term the DQL as DML. Whether select is a DQL or DML. At least I remember my early days. How many years before, 20 years before I remember. This debate myself and my friends used to have. You don't trust. At the time when I started learning the SQL 20 years ago, I will be discussing with my friends, my friend Vivek, my friend Sheikh, my friend Subramani, right? My friend Fazlur. These people and all, we used to, we were staying in a home in near Vadapalani, opposite to AVM studio and all. We used to stay there. At the time, we discussed at our home, hey, tell me, what are the DDL components are there? Tell me whether the select is a DML or a DQL. At that time, I remember what we discussed. Tell me the way the sequence of the SQL queries will be returned. Select and then from and then where, or select where and then from. Because in my college days, we had a database paper, but we learned what is select start from table name, not more than that anything we learned. We don't know how to even write that at the time when we passed out of our college, computer science engineering even. Okay, so it is obvious. But if you learn this foundation and all more efficiently, that will give you the complete foundation of the data engineering. This database knowledge, what I gathered initially in my fresher days, that gave me a complete idea of entering into data warehouse, application development, Oracle apps development, forms and reports development, or the ETL development, data engineering development, cloud data engineering development, everything. It helped me a lot actually. Even data analytics, even in the data science, it is helping me a lot. Okay, so the SQL is the core, the mother tongue for learning everything else. What we do, guys, if you are going to learn a language, without knowing mother tongue, can you learn some other language? Definitely not. You can able to relate with our mother tongue and learn any other language efficiently. Agree? I'm going to learn English means how do I learn? I interpret English into Tamil. Interpret English into my mother tongue, what I'm speaking. And then I'll understand about that English word. Agree? Same thing. You can relate anything that you are going to learn with the SQL. If you know the SQL foundation very efficiently, learning of any other language is not going to be hard for us. That is where SQL play a vital role. Okay, keep it aside. Let's move forward, guys. Okay. Some facts, some funny facts about SQL. SQL was originally developed by a person, somebody called the Raymond Bice and Donald Chamberlain, in the year of 1970 itself in the IBM Research Institute. They initially named it as SQL. People used to specify this as SQL or SQL or SQL, anything. We used to say it as SQL, but basically SQL is originally they have developed it as a language. Then later it has been started called as SQL, structured query language. They just named this language as SQL. Originally in the year of 1970, think about it, guys. Then the SQL has been transformed into databases. Then the databases has been implemented with the card rules and all, the relational database management system and all. Lot of features are being added into the databases by different companies like Oracle, IBM, right, Microsoft, and every companies. Then it got into the stage today. The databases got into the stage today. Okay, let it be. Some of the maybe like facts about SQL. The SQL queries have to be written in an order. In most of the databases, in most of the environments, the SQL has to be run or written in an order. In most of the databases, some database support some change in the order. What is order means? We have to write select first, from second, where third, group by fourth, having fifth, order by sixth, limit 7. These are all the mostly used, regularly used database clauses. We used to call it as clauses. Clause. This clause we used to write in an order. That is the fundamental, that is the foundation, that is the fact about SQL. But in most of the databases, in some of the SQL platform, we can write it in some different order also. It is allowed. It is allowed. We will be learning about that and all subsequently. Don't worry. In Hive, I can write from the table name, select star. Like this, if I write, it works in Hive, but not everywhere it works. I can write a query like this, it works in Hive, but not in all the platform it works. I'm telling you an example. So in general, if you are becoming a SQL developer, you are not working in some advanced component like Hive or Spark SQL or BigQuery or Synapse or somewhere else, Redshift or Athena, like this and all, you are not going to work. Let's assume. Then you have to follow a strict rule of what? The SQL has to be written in an order of writing the classes. Most of us know, who are not from the SQL background, very basic knowledge. If you say I have, you know what is select from where at least, or select from at least, you know. Right? Let's go and learn about all this slowly. But for now, yes, you can just write the SQL queries in an order only. But the way how it executes in the background may vary. You could not able to presume that so easily. For presuming that how this statement that I returned entirely will work, you have to go and understand about the database architecture. I'll take a very short span of time to explain you about the database architecture. Okay, wait for a while. However, I'll talk about the database and the big data lakehouse architecture later. But for now, I'm just talking about what is database architecture to a very core fundamental. Okay, we'll go and deal about it. So SQL has to be written in order. SQL is not case sensitive. You can write select in a lower case or you can write a select in an upper case. It works. It works. Okay. It is not case sensitive. The query steps don't happen in the order that you write. What I was telling, right? You may write select from table name where group by having order by and all, but actually the from will execute first. Then the where will execute second. The select will execute in the last only. In the penultimate stages only the select will be executed. So the order of writing the SQL can be in one way, but the way how it executes in the background is more optimistic. The optimization will come into picture here. The SQL engine, the database will decide what class has to run first, second, third, fourth, and all. But we just write it like an English statement. We are going to say what I select these columns and all from this table. Apply a condition filter where in mere English where city equal to Hyderabad, group by area, having the total number of people in a given area more than 10,000. I'm going to run a marketing campaign. I'll be writing a query like this in my customer base table, in my population table. I collect the population from some government sites or somewhere, and I'll go and write a query on top of that. How many people are there in a given area? I'll write this complete query, order by the count, the total top 10 count area I'm going to choose to run my campaign. Order by the count of data. Limit only 10 output in the screen. I don't want to see rest of the counts of the areas and people and all residing. Like this query can be written in any way to achieve the output as per your business need. All of a sudden, I just had a thought process of telling marketing. Maybe I'm going to run a marketing campaign. For that marketing campaign, I may write the complete whatever this statements as a query on top of the population table. I want to know, I want to select only the column of the area, comma, the count of number of customers present in that area from the population table, where I'm targeting only the city of Hyderabad, group by the column what I used in the select statement, which is nothing but area, having the number of customers greater than 10,000 in a given area, order by the count descending. So 2,50,000, 2,10,000, 1,55,000, 1,95,000, 85,000, like this. It will keep show all the areas with the number of customers. I wanted to limit to take only the top 10 areas where the customers base are very huge. Like this, if you understand the SQL to apply in any data, right, that is what our ultimate learning is going to be. Ultimately, I wanted you guys at least to go today out of our session by understanding what are all these classes, how it can be used efficiently. Okay, that is what our aim. That is what we have to achieve. Okay, let's try to achieve that. But I just gave you an example of this. Queries can be returned with all these. Most of these classes are covered here. Most of the classes we covered here. In a regular time when we write a SQL query, we use most of these classes. There are a lot of other things are there, but this individual query, when I'm going to write, I may use minimum select from. This is mandatory. Select and from is mandatory. Without using select and from, we can't have any queries running. Select SQL queries can't run. The DQL queries can't run. Data query language can't run. But where is optional, group by is optional, having is optional, order by is optional, limit is optional. But we are applying all this to achieve a marketing campaign. I want to understand how many customers are belonging to the top 10 customers belonging to an area. I want to know that means I use all these classes obviously without any doubt. We'll come back to that part. So we have to write the order of SQL in this way only. Okay. Select is where you pick the final columns that appear in the table with the query options. The syntax is select the column name and the alias we can give for that. Alias means what? We can rename the column to produce the output as per like our need. So select is minimum needed and the from class is minimum needed as I was mentioning, which is going to finally produce the result. The from table can have 100 columns, 1000 columns. I am going to produce only whatever the columns that I am going to intend to show to the output. And I can rename the column with an alias given also. Possible. Right? Alias as an expression with as or without as. Select a column name from a table. Directly will display the column name of the table. Select the column name as some other name from the table you can give. Or select column name space another name what we wanted to display the output. We can mention. All the possibilities are there. We will cover that. Wait for a while. So some funny facts about writing SQL queries. Just you can go through this. Okay. This is what we are going to learn more in detail. We have SQL developed by some people in the 1970s. It's 50 years before content we are learning. Even today, it is famous in the market. Even you get opportunity today in a company as a SQL developer, as a data engineer. In a data engineering interview, if you go, being as a big data developer, cloud SQL, cloud data engineering developer, anybody you go and attend the interview, you'll be having most of the interview, 70 to 75% of your interview will be more towards aligned towards SQL. 50 years before component we are learning now. 54 years old component we are learning, which was introduced 54 years old, but still it has its fame. It is the mother tongue. We can't change that. But that mother tongue has lot of interesting factors, not case sensitive. We have to write the queries in some order. We have some of them are mandatory, some of them are optional. If we use something, we have to use something else for sure. For example, if I select a column and if I'm going to have a aggregation performed in that column, in the select statement, I have to give that in the group by, obviously, there is no doubt in that. If I'm going to filter the data based on the aggregated value, then I have to use having rather than where clause. Like there are lot of rules, lot of regulations we have to follow, basically. That jargons are, that nitty-gritty only we are supposed to learn in our learning subsequently. Okay, we learn that. Okay, so we can bring the column from the table and restrict the number of columns by writing the select statement from a table, and we can rename the column name or we can display the column name as is. But one thing you keep in your mind, the select, the query whatever I'm writing is not the way how it is going to run in the background. That is also a fact in the SQL. Okay, any question on this before I move next? Okay. RDBMS architecture of a database. Okay, very simple architecture. It is not very costly and all, very heavy and all. Okay, I am going to write a query. The execution of query is going to happen like this altogether. In a fundamental level, if I'm going to write a query like this, guys, okay, from my database table, select owner from a table called cats or whatever. I'm having a pet shop. I wanted to maintain the owners of the cat's table. Okay, owner of a cat called Daisy or whatever the name that I have, where the name is equal to Daisy. Like this, I am writing a query. This is a minimal fundamental query we may write regularly in the SQL environment, in the database environment. When I write a query, how the database is organized. The database will be kept in a server. The server can be a Linux server or a host, I can call it as. The database can run inside a host or a server. You can call it as in any name. I'm going to buy a Linux server or Windows server or any other server I'm going to buy. And I'm going to install a database server software in this computer, in this server, Oracle database or SQL server or MySQL. If I'm going to install Oracle database, mostly the preferable operating system will be Linux. If I'm going to install SQL Server database, the preferable the operating system will be Windows, because the SQL Server is the component of Microsoft company and Windows is the operating system of Microsoft. So I will go and buy a server. Inside the server, I will form a database. Okay, now a database is running, a database server is running, a database is running. This is a database. The database comprised of, or a DB server comprised of, this is a host, a computer. We call that as a server. A server, we call that as server computer. We can call it as. Inside the server, we will be running a database software. That software we call it as the DB server, database server. The software which is running inside our Windows or Linux server, we call it as a DB server. The DB server comprised of, as how I have the image mentioned here, the DB server comprised of the subject areas, databases, or schema. Database or schema we used to call it as, or catalog we used to call it as. Multiple name, different name people used to give for different databases. In different databases, they will give different name to represent the way how the database is being divided into. Basically, I have a database with the capacity of 100 GB. I'm going to create multiple databases in that 100 GB database server to hold all retail data, all wholesale data, all marketing data. We'll create multiple databases inside a database server to maintain the related content, related data, related subject of data. That is how the database will be organized at the holistic level. But how it works internally, we'll discuss very quickly on that. I don't want to go deep into it. Take any one of the database server example. Oracle is a pretty better database server to understand about how the database works in the background. Okay, we'll consider this like an Oracle database, let's assume. And we are going to learn about how the Oracle database works when you write some query. What is a database server? What is maybe like a client tool? What is the source for sending the data to the database server? We call that system as what? And the database server will be operated in such a way, how it is going to be get operated if I'm going to write some queries. This part we are going to understand right now. If I'm writing this query, how the database will help us produce the result. In the database, how this query will be running and how we get the result out of the database is the part we are going to learn right now. Before that, how we can go and connect to the database. Before that, how the data is sent to the database. Like this, we are going to first understand. Overall things we are going to understand. But before going into that and all, a database server is going to be created under a Linux or a Windows-based server. One computer we buy in a Windows or in a Linux-based operating system-based server we buy, not a normal computer we buy. We buy a non-commodity hardware. We don't buy a normal computer shop available computer, we buy some special computers with some huge capacity, resources available. We buy servers by spending lakhs and lakhs of amount. Then we go and talk to Oracle or Teradata or DB, my IBM or Microsoft to provide me the respective database servers to us. So they will help us providing the software to us to install and configure. They will help us with 100 GB capacity. I'm going to allocate for this database means they will help us giving 100 GB capacity on this computer taken for using this database in our server. Then we will do what? We will go and create the subject areas, the databases. So the name I'm using, database server, which is a software that I installed. Inside the database server, we create databases. Database is nothing but like a folder. You are creating a drive, C drive in your computer. You are creating folders, right? That folder is like a database. Inside that folder, we may have what? Inside the database, we will mostly have what? In a database of marketing, we may have tables. So this is table number 1. This is table number 2. This is table number 3. This is table number 1, 2, 3 of a database. We have a wholesale database created. Inside the database, we have a customer table, transaction table, payments table, logistics table. Like this, we can have databases created under which the tables we are going to create and load the data into the table. From where, how the data will be loaded to a table. Mostly the database systems will get the data loaded into the table via some applications, via some web application, via some desktop application, via some devices, via some mobile applications. Anyway, the data will be collected from the OLTP systems, online transaction processing, point of sale systems, the sale where it is happening, the transaction where it is happening, the system of engagement where it is happening, system of engagement, where the real engagement is happening, in which system the engagements are happening. From that system, the data will be collected and stored into the respective database tables. Into the respective tables, the data will be stored. I'll maintain the mobile application table. The mobile application can be used for onboarding a new customer, registration data. I will keep the data in a registration table, customer information table. When somebody purchases some product after registering, then I'll keep that in a transaction table. Right? Like this. I'll have multiple tables maintained to capture the multiple page of this application, multiple activities performed on this application. For one application, I don't create one table. I'll create multiple tables. The data can go from this one application to multiple databases even. Some customers are going to a mobile application and doing a retail transaction. Some customers are going to the mobile application. He's only seeing the data, but he's not purchasing anything. He's seeing only the product, but not purchasing something. So I have an opportunity for asking my marketing team to go and reach that customer to pull in as a customer. So this data, whoever did not perform any transaction on the mobile application, those data will go to the marketing table, marketing database. Whoever went to the mobile application of whatever I have, I'm enabling for my customers to use in the internet, those people are going to perform a bulk transaction. 100 products they are purchasing. Then I'll consider that as a wholesale data. And I'll collect those data into my wholesale database table. Or I'll go and collect the data as a retail data. Like this, based on the operation the customers perform in the front-end applications or in the mobile applications or in the point of sale system or in the devices, I will go and store the data into the respective database tables. By that way, it is easy for me to categorize and do the analysis or maintenance of the tables data. Everything I can do efficiently. You understand fundamentally how a database gets the data from? This data only what we did is in our yesterday's session with the weekday team and today's session with the weekend team, what I did is I brought this database table data only into our HDFS file system by using the tool called Scoop, which internally use the framework called MapReduce or Mappers. Agree? Agree? We are going one level down. We are not dealing about the database. Database, let them maintain. Somebody maintain. I don't bother. After we bring the data to our HDFS file system, we are also going to write queries on this data only by leveraging a tool called Hive or Spark. Or we are going to bring this data to not the HDFS file system. We are going to take this data to the cloud storage layer. And we are bringing the data from the cloud storage to the HDFS either. Or we are going to create a table on top of this cloud storage in the name of BigQuery table. In the name of BigQuery table. See, the data, whether it resides in a DB server or in our HDFS file system or in our Google Cloud Storage file system or in our ADLS file system or in our blob file system or in our S3 file system, we are going to write queries on top of the data, which is not only going to be collected from one database, multiple databases we are going to collect the data from. Multiple source systems we are going to collect the data from. And we are going to write queries on top of that to do the broader analysis for our organizational growth. That is what ultimately we are going to achieve in our entire journey of the data engineering, data analytics, data science, everything we are going to do. Agree, team, what I'm speaking? So this will be further propagated. Our life is not stopped here. Our life, the data engineer life starts from here, not stopped here. It is started from here only. After I bring the data to our data lake, our lake house, our big lake, our delta lake, our data mesh, our data fabric, once we bring the data, database is only one term, which is available for more than 54 years. If we talk about some 54 years old content, you'll get only a opportunity as a database developer who is going to work with the front-end application people to go and onboard the data, collect the data, and store it into the database tables. This is the only opportunity what you can get out of this. But if you are going to expand yourself into a data engineering, into the cloud engineering, cloud data engineering, big data development, big data analytics, if you are going to enter into that layer, means that is a next layer of the database. So for the database, the data is going to be collected from the front-end applications or from the point of sale systems, system of engagements, where the data will be brought to the system of records. We call this system as a system of records. From the system of records, the data will be brought to the system of insights. SOI. SOE, SOR, SOI. We have three systems available in this world. Overall, only three systems available in this world. System of engagement, system of records, system of insights, which is a universal fact. I'm not telling of my own this one. Don't think, Irfan, you are telling some story here. No. These three systems are available in this world. Overall, we are falling under any one of this system. If you go and see yourself, you will find you are belonging to any one of this system. I will give you as a task in a later point of time to identify, guys, tell me, you are all belonging to which system? Identify that and come back like this, I will tell to you. In a later point of time, I'll be giving you an exercise of identifying. Guys, go and identify. You are belonging to which system in your organization? I'll give you this exercise in a later point of time. In the interview discussion and all, when you are going to start, I'll tell you, you are belonging to system of insight, system of engagement, system of records. You will be finding you are belonging to any one of this system in your organization. If you could not able to find, I'll help you find. But how the total systems are connected in an IT world, My aim is teaching what is RDBMS architecture. Somewhere I just covered. We have different systems available in the world, in the IT environment, in the entire system environment. We have three systems: system of engagement, system of record, system of insights. System of engagement means where the engagement happens, where the front end applications or maybe like middleware, everything runs. And the system of record is where the data will be collected and stored. It is not only a database server, it could be a file server also. It could be any storage layer where we store the data. And the system of insights where we create insight out of it, where we derive the insights out of that to help our business to grow further. This is going to feedback our systems to open further in the entire world. Okay, guys, keep it aside. Keep it aside. In the real time, do we have query each time for pushing the data, or this will be automated using Hyven Spark? What is Hyven Spark? Let's not worry, Lokesh. I'm not dealing about that right away. Okay, let's worry about what is database today. Okay, what is Hyven Spark is the part we are going to learn for another 6 months. Today we have very minimal time of 3 hours. So we have to learn only what is database. Hyven Spark is, I'm just using some term called Hive is also, or Spark is also a SQL environment where we are going to do more of insights. In real time, each query is pushing the data, or this is automated with Hyven Spark. In real time, everything is automated. You don't do any work manually. That is what I would say. Not only Hyven Spark, even this is automated. Bringing the data from the database, from the front-end applications, putting into database to our Hadoop cluster or cloud environment to generate the report out of Hyven Spark will be happening automatically. No doubt in that. Automation anywhere, automation everywhere. That we are going to see. But however, who is going to automate is the question. It is automated, but we are going to automate. Okay, let it be, guys. Leave it. Okay, let me just create one more slide of this, since I know like we have used this slide heavily for other purposes. Let me go back here. Okay, I'll just use this slide once again for a better understanding of the database architecture. Okay, now you are able to understand at least this slide is comprised of what and all, right? Let us keep it like that. Okay, now let's go back. I have a database. Okay, we are getting the data from the point of sale system or the front end applications or any of the devices. We are going to get the data loaded into our database server, and we are going to start write query to write even the data into the tables or pick the data from the table. Let's concentrate on not writing the data to the table. Let's assume the data is getting returned into the table where somebody already have performed the data definition language activity of creating the databases and tables. Somebody have performed the transaction control language to control the transaction if somebody is purchasing or not purchasing. If purchasing means I'm committing, I'm permanently storing the data into the database table. If they are not booking the ticket, then I'm going to delete the data from the table. I'm going to revoke the data, or I'm going to roll back the data from the table. That is transaction control language. Who can access what table? I'm defining that using the data control language. The definition of the tables I'm creating using DDL. The transaction control I'm maintaining using TCL. The data control we are doing with DCL. And the people who are all the transaction that is happening when they perform a write operation, delete operation, or store operation, or whatever, the DML operation, insert, update, delete, somebody is going to do using the front end application, may happen here even in a form of DML. DDL, DCL, TCL, DML, everything may happen by the front end applications or systems on top of our database tables, on top of our database running in a Linux or a Windows server. Forget about all this. Now, the database will do what? Of whatever the data that I have returned, it will go and write into his one server, into his one computer hard disk. It will go and write, not into multiple computer hard disk. The difference between the database and the data lake or lake house is This database has only capability to write the entire data into one computer. Agree? One computer hard disk, the data is going to be returned overall. The data will be stored in the underlying storage of the hard disk in a form of something called data files. We used to call that as a data files. Internally, it will be stored. And this database comprised of, this entire database server comprised of not only tables and databases. We have to provision the data to the customer from the table, from the databases, right? How we can provision it? By having some resource enabled. What are the resources the database will enable? If I'm going to log into a database, how can I log in? I will be opening in my Windows computer or in my Linux or Windows PC or somewhere. I'll go and open some tool first of all, or I'll open some web GUI first of all. From that web GUI or from the tool, GUI or the tool, I'll go and mention the IP address of this server. So via that IP address, whatever I'm going to mention by choosing this database option, add a new database connection, username, password, IP address, port number. In this computer, 65,336 ports are available, out of which I'm going to use only one port, 3306 port number, where this particular database is running in this computer. I am going to use this tool to hit that particular port number to connect with this database by using the username and password via a tool called, some tool called DB Visualizer or Workbench or some software I'm going to use to connect to the remote database running in somewhere in this world. Once I connected by using the username, password, the IP address, port number, I could able to access the database by mentioning what is the name of the database, maybe like core banking database. Like this, I can able to access. Then I can access the tables inside the database subsequently. That is what our aim altogether of writing this query. I'm going to say what, hey, from the core banking, I have a payments table. I want to access the payments table from your database server. Like this, if I go and write a query like this of something like this, select owner from table name, where name equal to Daisy. Like this, I'm writing a query here. If I write a query, what happens in the background? The query will be sent to the database server. Or first of all, the connection that I established to the database server, right? What the database will do? The database will give me some work area, some memory container. It will allocate some space. It will allocate for the connection to establish. First of all, it will give me a small workspace in the database environment. We call this as a PGA. Needless to remember, needless to understand, needless to know about what is the expansion of PGA. But the expansion of PGA is, especially people from Oracle database administration side knows about it. What is PGA, guys? Anybody is there to raise your hand? Yes, I know it from. Program. Correct. Program is correct. Global area. Great, Myron. Program global area. So the connection, once I establish to the database server, the database server will give me one small space, one small memory space, one small container, like a yarn child. How yarn child will give a child for us to sit, make our mapper sit and work the same way. For the user who connected to the remote database, the database will give us a program global area created for us once we connect to the database. But all these program global areas are controlled inside the system global area, SGA, PGA kind of. The environments are maintained by the database server managers. That means the Oracle or any databases they design, they have this kind of logic in the background to allocate some space for the user to connect. If you feel like, hey, I connected to a database, pulled some data, means there are a lot of things are happening in the background. When you write a query, now you connected, you got some memory space in the database server. Now when you write a query, select owner from table name, where name equal to Daisy. Like this, you are writing a query. What happens? That query will go and get fired into this database server, the database engine. The database engine will do what? Will go and pull the data related to that particular data set. See, these are all some names given for the data, but internally the data is stored in a physical file formats. These are all just the name, the metadata mentioned, how the table has to be, how many columns it has to have. But the data will be stored internally in a form of file only. Keep that in your mind. When I say, hey, I'm going to store the data into a database table, you say what? The data is stored in a table. But actually, the data is stored in a form of files in the underlying hard disk of the database server. Okay, don't say the data is stored in the table. The data is stored in the data files of the table which is referring to. In the same computer, it is stored. Right? We say Hadoop FS minus cat some file, but the file content is stored in a form of blocks inside some data nodes, right? The same concept, but it is stored in the same computer, not in a different computer. The structure will be kept here, but the data related to the structure will be kept in the underlying hard disk of the database server. So the data from the data files will be brought to the memory. From the memory, the data will be provided to our calling environment. But when the data is brought to the memory, to the program global area, how it will be brought? First, it will go and run from class in the background. First, it will bring all the cats related data that is stored in the file. All the cats related data is stored in a data file in the background. That data file will be first loaded to the memory. Then I'm applying the filter of DAISY alone. So if the data is loaded into this database memory is 1 GB size, means from the 1 GB it will filter only one record or one column value called DAISY, which is going to be 100 bytes size, let's assume. So balance 999 or 999.99 MB of data will be removed out. First, the data of 1 GB will be brought from the data file to the memory. Then what happens? The data whichever is not applicable, because I applied the filter, that will be removed out from the memory. So balance 999.99 MB of data will be deleted from the memory, because I need only one record. In that one record, I need only one column. That column will be displayed as an output. So from the database data file, the data will be brought to the memory container. Into the memory container, that is program global area memory container, allocated for every customers, every users who logged into the database. Now, the from cats will be executed and pull the cats data from the data file, the cats and people data we have in the data file. From here, only the cats data will be brought to our program global area. Then all the cats data will be brought to the program global area. It will identify only what record we wanted. Only one record of DAISY alone it will identify. Then from the DAISY, I am having owner name and the ID. I am taking only the owner name. So what is happening here? Only a particular row and a particular column is being finally selected. But how it will do the selection? First, it will bring the entire cats data from the data file to the memory. 1 GB of data will be copied to the memory. From that 1 GB, it will ignore 999.99 MB of data from the memory out. It will throw the data out from the memory, retaining only the 100 bytes of data for that given row. It will apply the filter after bringing entire data. So from cats will bring the entire 1 GB of data to the memory area. Then once I filter that data with only the DAISY name, what it will do? It will go and reduce that 1 GB to 100 bytes. Let's assume this data is 100 bytes. The row is 100 bytes. It contains some more rows, some more columns. From the 100 byte, it will receive finally 1 byte of content in the result displayed in the screen. But how much data is brought into the PGA is 1 GB. How much data it is going to give to me in the output screen is 1 byte. This is how the database operates, actually speaking. So if you see a database comprised of, a database server comprised of databases and the tables and the underlying hard disk storage. Storage it has. The storage contains data in a form of data files. Data files. If I go and write a query to connect to the database, it will create the system global area for every user connected. The system monitor, process monitor, SMON, PMON, like lot of other components run inside the database server. I'm not talking about all this. One memory area will be allocated for every connection that I'm establishing. The user is connecting to the database means for every connection, a memory area will be established. When I write a query in the user environment, the query will go and fired in the engine. The engine will go and bring the data related to the query what I wrote to the memory area first of all. Then it will go and apply the filters in the terms of rows or in terms of column and produce only the result what I needed. From the bigger result, it will give the smaller result. Then the smaller result will be sent back to the user who wanted to see the result. This is how the database architecture works. With me in this or not? So this proves two things. Whatever the query you write, it is not going to run in the same order that you wrote. And what the database is doing, if you write a data from a table, it is not bringing the data from a table. It is bringing the data from a file to the memory in the name of the table. Table is for your reference. Table is just for your naming convention. But the table will be having the data stored in the file internally in an encrypted format, in a serialized format, in its own trial file format. The data will be stored in some special format called trial file. Trial format it will store. We have a lot of other server components are there, but all those people are going to work together to provide you the data in the memory, and from the memory we are going to apply the filters with the query what we wrote. It will write that language in a C++ and C language. Whatever the query that we wrote, if you consider Oracle, the Oracle will convert this query into C and C++ language and execute all these filters and everything in the memory area by bringing the data first. First it will bring the data to the memory, then it will filter the data. The filtered final data of whatever the column that I wanted, that will be produced as a result in the screen. Lot of hard work is happening in the background, but we are finally seeing the result just like that. PGA size gets dynamically changed based on the individual table size. There is a limitation. It will have a limitation of giving some 100 MB, 200 MB. So what happens? Let's assume 100 MB size it is going to give. It can't able to give. I'm going to bring 500 GB data. Let's assume my database has a server has an overall RAM capacity of only 128 GB, but I'm bringing 500 GB of data and process. Can the PGA can expand to 500 GB? Not at all possible, right, Karthik? So PGA has a limitation. This much only I will allocate maximum for a user. That will be defined by the quota allocation by the administrators. Administrator will allocate the quota. How much maximum this user can occupy the PGA memory. It will expand up to how much I allowed to use by the users. But based on the volume and all, the PGA could not be expanded. In order to get that kind of expansion happens, we had to go to our big data environment, because big data has no limitation. Our capacity can be increased in this computer or that computer or some other computer. By that way, our expansion of the capacity can be enormous. But whereas in a database, it's a single server. Though the data I'm going to process 500 GB, the PGA will be allocated to a limited size, maybe 1 GB, let's assume. Then how can I process 500 GB of data? First 1 GB, second 1 GB, third 1 GB, fourth 1 GB. Like this 500 times I pull the data from the file, apply the filter or whatever. Then I will cumulatively add all this data to produce the result. Following me, Karthik? Right? So the size is not going to be expanded drastically and all. It may expand dynamically, but to an extent of how much I had the capacity allocated for the given user. Like these are all more internals of the databases. Quota concept and all these are there. Forget about all those concepts. Fundamentally, The data in the database underlying file system storage in a form of data files will be collected to our memory area. And in that memory area, we are going to have the data processed and produce the result to the user. That's it. That is how the database works. Now, post the break, we'll go for a break. Post the break, we are going to connect to a database. Let's do that operation, right? Let's go and use the PDF that I have shared in our drive. Please download this PDF and keep it in your Windows computer. Open this PDF and install the software that I have given. Maybe before you go for the break, yes, MySQL Workbench software. Before you go to the break, you just download this software in your Windows computer and do the installation. Maybe whoever did not complete the installation, please do the installation coming back from the break. Okay. So what is the time now? If you have any issues in the installation, I'll help you guys. So 6:43 is the time, right? Let's resume back at 6:53 p.m. IST. Okay. 6:43, 6:53 p.m. IST will resume back, guys. Who did not complete the installation, please do it. Okay. We'll come back and start work on something. Fine, guys. Okay, I'm back. A minute ago, maybe a minute before. Anybody is trying the installation, having some issues, please let me know, right? Otherwise, we are going to start work on or maybe start connect and see for all of you whether it is connecting or not and all. And then we will go on further, go and start do some hands-on exercises, some sort of like learning after getting some basic understanding of the components. I'm going to take you guys to the actual hands-on part of first creating the tables, first creating the databases, first creating the tables, and doing some sort of operations on the DDL commands. We are going to see that over here in a broader way. Okay, let's go and do that. So before that, anybody having any issues in the installation? While we are going to connect to the database, we'll try to understand about fundamentally what is what and all. Okay, I'm going to first take you guys to fundamentally make you understand this in a layman perspective. I told, right, that I'm going to do right now. Okay, maybe let's start this and do. And in the meantime, I'm hoping you guys are installing the software. Okay, I hope you guys are downloading the software from the drive, installing it. Is my voice is breaking, guys? Others? Okay, maybe Bharat, you have to check your connection. Maybe. Okay, fine. Okay, team. I hope you guys are available. It seems. Let me move forward. Okay, so I hope like you guys are downloading this particular PDF and you are having this PPT what I'm using currently. I put a wrong version earlier. Now I put the right version. And the practice queries I have given here, out of which only one query I added here so far. I have a couple of other queries to give you guys as well. But first, let's go and deal about the DDL and DML for us to get some data generated. We need to have some data created for our purpose. Okay, we'll go and do that activity first. First, let's go and have the database, schema, tables, fields and columns, data type, record or row, understand first of all. Let's do this understanding the components of a database, fundamental components of database. There are a lot of other components we have in database. We use indexes, materialized view, lot of other concepts are there. But at least in this first cut, I'm going to cover not all those concepts of views and all. Views, indexes and all, I'm not going to cover right away. Not mandatory. Indexes is not very mandatory in our learning, at least. In being as a data engineer, we don't need indexes much of, but views are important. But I'm going to primarily cover the core components, whatever I'm highlighting here. Whatever I'm highlighting here, I'm going to cover right now, first of all. Okay. We will keep this database architecture aside. We will again hit back this architecture, right? Again, we realize this architecture soon. But before that, I'm going to take you guys until you guys install the software and do all this activity. I'm taking you guys to some ground fundamental things. Okay, so let us relate these 2 pages of our understanding in a layman perspective very quickly. Let us learn these things easily of what is DDL, how much priority you have to give for DDL is priority 2. How much DML you have to give the priority, data manipulation language I wrote in the top. Maybe this one will help you understand what is it. Somebody asked, right, what is data query language, Irfan? I have wrote it firmly here, so you can make use of this for learning purpose. So the high priority I'm giving for the last item here. Rest of all are priority 2, priority 3 item. But however, we have to understand about what is a database schema, tables, field, column, data type, rows, record row or view. This kind of concept and all we have to learn means. Let's take our Excel as an example, our G sheet as an example. Okay, we'll take our G sheet as an example. Maybe I'll go and enter into our Google platform. I'll go and create a G sheet. Okay, so in our Google account, I'm creating one. This is my Google server. This is my database server, let's assume. I'm creating one database in it. This is a database server, you assume like that. I'm creating a database, which is nothing but a spreadsheet. This is nothing but a database I'm creating to maintain our aspirants information. So I'm creating one database called aspirants DB. You can call this sheet name as aspirants DB. Aspirants database I'm creating. What is a database? Database is a container of related objects. Related objects in the form of tables, we use indexes and some more components of the databases. Okay, so database is the container of all related objects. Very direct. What is the definition of a database? Database is going to contain, I mean, for us, it is a physical container, but actually I told database is just a name given. Internally, it will be stored, every data will be stored in a form of files only. We see, I have some data kept in my database. If you see here, this G sheet is a link for me. I got one file created. That file contains multiple tabs in it. This entire G sheet, I'm considering it as a database. Internally, it will be stored as a physical file. That is a different story. The same way, the database is nothing but a container of all related objects. The objects could be tables, views, indexes, and a couple of other items we have, but I don't want to make you guys confused talking about all those. Minimum you consider tables. Database is a container of the related tables. You can consider like that for now. Database is going to have the related tables in it, stored in it. Take it lightly like that. It's a container of related tables. Related tables means what? I'm creating a database called aspirants DB. All aspirant related data I'm going to keep in this database. Which are all the aspirants we have? We have weekday 34 aspirants, right? And weekend 45 aspirants. I'm creating 2 tables inside the database. So what is database? Container of a placeholder of a name given for holding all related tables. You can say it in any way. What is a schema? It's an alternative name of a database. We can interchangeably use database or schema. Both are alternative. We can use the term called schema or database. In some places, people use the term called schema. Some places, people used to use database to denote database only. Schema is nothing but a database. Schema is a database. We can interchangeably use the term schema to denote database. Denote database or catalog. Any name you can give for denoting a database. That is schema. Schema is an alias of database. Yes, rather than using database, we can use a term called schema. For example, I'm doing two things here, guys. One is I'm going to create a database in a layman perspective, or a schema in a layman perspective. This aspirant DB is a schema I created, or a database I created. I can mention any name for that. Okay. Now I'm going to connect to our cloud database, whatever I got created in a server. This is my DB server in cloud. And this is the database running inside the cloud. This is a database server running inside the cloud. I'm connecting to the database server using the web GUI, not by using the tool which we are going to connect soon. The workbench tool we are going to all connect using that soon. But I'm going to connect using my web GUI itself to the remote database. And I'm going to create one database called create database. Some database name called weekend 45 DB or aspirants DB. Just I'm giving a name as DB for an understanding purpose. Rather than mention like this and create a database, I can mention create schema name. Both are same. You give either create schema name or create database name. Both is going to create a database in this server only. It has two databases currently, right? Once I create this database called aspirant DB, it created a database over here in a name called aspirant DB. Rather than using database as a term, if I'm going to use schema as a term, or aspirant schema, no one will call it a schema. They will call it still as a database only. But it is denoting the database only. People use interchangeably schema, database, both are same. You are able to understand now. After I create this, you are finding a database only added in this environment. Nothing called schema is added. The database only got added here also. Clear? The database versus schema means what? Both are same. Denoting the database in a different name. Alias of a database. But alias means people used to mistake this as saying, hey, rather than using the name called aspirants DB, can I use ADB? ADB is alias of that aspirants DB. Like this, they will consider. That's the reason I'm not using the term called alias. But however, yes, whatever you told is also correct, Mohan Raj. Schema or catalog is an alias of database. Database can be called in any of this name. Applicable. Correct. Team with me? With me, what is database? What is schema? Every one of you. What is a table? As such, table is a container of what? Data. Table is a container of data in a form of rows and columns of a defined data set. Or forget about a defined data set and all. Of a structured data set. Or table is a container of data in a structure, in a form of structure of or in a form of rows and columns with some structure defined. That is the reason we are calling it as a data definition language. Defined. Already we defined some structure for the table. Based on that structure only, the data is going to be held in the table in a format of rows and columns format. What is this table means? What is this table means? Table is nothing but the container of data. I'm going to say what inside this database. I'm going to the database called aspirants database number 1 or aspirants database. Inside this database, I'm going to say go inside aspirants database. So now I'm pointing to this database. Whatever I do the operation here in the down, it will be doing in this database only. So I'm going to create one table, create table, table name. The systematic way of learning SQL is what? Registering the Syntax of the SQL. Create table, table name. Create database, database name. That is how we have to register. Then only we can able to write the queries efficiently. Registration of the syntax and semantics is very important. Then only you can say, I got the grammar learned. To use English in a right way, we have to know the grammar. We can use the English without using the grammar also, that is fine, but it will be looking more beautiful if you use grammar properly. So the SQL also, if you write with the grammar applied in it, that will be more beautiful to write, more easy to write, more strategical to write. So the strategical part here is, if I'm going to write a SQL query here, if I'm going to write a SQL query here, I am going to use a syntax from my brain, from my mind map. I'm going to have this mind map brought and applied. Okay, I'm going to apply that while creating the table. So create table, something called W45 TBL of the ID of the student of type integer, the name of our aspirant of type varchar of 100. Like this, I'm creating a table. Table is a container of data, but I defined the table first of all. It is not containing the data right now. First, it is been defined. It is been defined in the database called aspirant DB. In a schema called aspirant DB, I got a table got created. I got a table called okay. What happened is, in the database called core banking, it got created. The use aspirant DB. I hope like I did not execute it. It is not jumping to the aspirants DB. So I'm going to create the table in the aspirants DB. I'm mentioning the database name dot table name, schema name dot table name. You use any word here. Schema name, table name. Suresh, both are same. Whatever you put here, let me put here again. Let me put here again. Because this is always a confusion people has. Schema equal to database equal to catalog. People use in different places this different terminology. All are correct. With me, Suresh and everybody, it is correct. Yeah, equal to data set. Great, Punithraj. Data set. Sometimes we use the term called data set. In BigQuery and all, we use data set. We don't use database there. Great. Like we have multiple names, but the most common name is database. The second common name is schema. Third common name is catalog. Fourth, fifth common name is data set or whatever people are using in different environment in different names, but it is nothing but the container of the related tables, related objects. Database or schema or catalog or data set are the container of related objects. You have to register in that way. This sheet is a container of related. Where is the sheet? This sheet is the container of all related. I mean, like this Google Sheet is a container of all related tabs. I have two tables created inside this sheet, inside this database called aspirants database. Two sheets I got created. Okay, this is a table. Table has been defined with a structure. I'm going to say what? Hey, let me create a table with a structure. I'm going to create a table with a structure. This is the table I'm creating. The structure of the table is ID and the name. The ID column is going to be of type number. So I'm defining some rules here, how the data type of this column has to be, right? I'm going to define this column has to be of what type, actually, the column statistics, like more column action, what this column has to be of, the range of size it has to have, and I mean, like how this column has to be of the type and all, the column statistics value I'm going to take, like this and all. I can define the structure of this column. Maybe let's not consider this G sheet, let's consider an Excel sheet rather. Okay, Excel sheet. I have an Excel sheet called assignment SFM flowchart. In that I have sheet 1, sheet 2, sheet 3, all are tables. So in this I'm going to create one table with a column called ID, with a column called name. This column I'm going to define a structure, saying what all the data placed into this column has to be having a format. What format? It has to be a number format. Number format without decimal spaces. It needs to have anything that I have in a number format. It has to be stored. This is not to be supposed to be a number. This column has to be of a format of some string or character, or some general value, some general string character or number or anything, or text I want to have. This column should have the text value, or I'm customizing this column to have a date in some format accepted. Like this, I can go and define the structure of the table columns. That is called the defined structure. I'm defining the column structure. So any data that is going to come here, follow the structure what I mentioned. I can't give one more column here. I can't change the data type of this column. I can't put if font here. This is a number column. You are writing it in an Excel sheet, fine, but you can't write it in the table like this. It won't accept. So we are defining the structure here that forms a table. So now we have a table with how many rows available, how many columns available, guys. This table contains, the table name is table number 3. This table contains how many columns? 2 columns. How many rows? 2 rows. 2 rows. Right? So a table is a container of data as such we are telling, but actually the table will be internally having the data pulled from a storage files, actually speaking. But for us, let's treat the table and data, everything is kept together. Both are residing together, let's assume in that way. But actually speaking, in the databases, when you query the table, as per the internal architecture, the data will be coming from the file and apply the data into the table structure when we go and query the tables and all in the databases. So we got a table defined with the structure. That is what I mentioned here as a definition. Table is a container of data in a form of rows and columns with some structure defined. So I just first created a table with some structure defined with the help of what? The DDL. And I'm going to store the data into the table in a form of rows and columns by using DML. This is where the DML and DDL plays a role, what we are going to do right away in another few minutes. So I completed my DDL activity. This is called DDL. Whatever the database I created, schema or database I created already, this is a DDL. And this is a DDL. This is a DDL. And what I am doing here is a DML. DML means what? Data manipulation language. I am going to insert into table name, schema name dot table name, database name dot table name, dataset name dot table name, catalog dot table name, values of 1, Irfan. Insert into table name, values of 2, Rajesh. Like this, I am going to store the data into the table. I'm inserting 2 records to the table. Insert into table name, values of so and so. The table does not exist, it is telling. Okay, let us create the table. Okay, I'm going to store the data into the table. Now, I got the table created, storing the data into the table. 2 records got inserted. This has happened because of I performed the DML operation. So now when I go and query this table, I call it as DQL. Select star from this table. I'm doing DQL, data query language. When I do this data query language, what is happening in the background is from table, it is going to pull all the data from the data file where this database server is storing. From the data file, the data will be brought to the program global area. In my remote cloud cluster, in my remote cloud server, cloud database server, it will be brought to the memory area. Then it will choose what are the columns I'm selecting. It will select the columns. What are the columns I'm selecting? Maybe I'm selecting the ID column alone. So from the database, it will fetch how much bytes of data from the underlying file server of the database. It will fetch 1 plus 5 to 1 plus 6 totally. First row it is fetching 6 bytes. Second row it is fetching 7 bytes. And then since I'm picking only one column, it is going to reduce this first row 5 bytes. It is going to drop out, and second row it is going to drop out 6 bytes. So it is going to ultimately give 2 bytes worth of data in my screen. In the database side, the data has been brought from the disk architecture wise something. The data stored in the data file related to this, pertaining to this table, is brought to the memory. All the data is brought to the memory. The 2 column values are brought to the memory. 2 rows are brought to the memory of size 6 plus 7. Totally 13 bytes of content has been brought in. Then from the 13 bytes, the data is reduced to 2 bytes and provided the result to me in the screen of my desktop. Able to slowly understand the architecture, how it works in the background. But I'm telling what I queried a column called ID from a table called WE45 table present in the aspirants DB database. I queried a column which contains 2 rows, which returned 2 rows from a table present in a database. You are able to connect all the dots now. All the dots of architecture, all the dots of what is a database or a schema or a catalog or data set. Table is a container of data in a form of rows and columns with some structure defined. I'm defining the structure. I'm defining the structure here. ID is an integer column. What is a data type we have to still learn? ID is an integer column. Name is a varchar column of size 100. Like this, we have different data types available in every database. Different databases supports different data types. That is a different story. Then we are performing, first we are doing DDL operation, then DML operation, then DQL operation. And this is where we perform more operation. The DML, DDL and all may happen once or sometime, not regularly, but the DQL will happen more frequently. The data will be brought to the table once for all, or continuously once in an hour, once in a day. But the select statement on top of the table will be executed by every people across the org, regardless of whoever it may be, whoever you may be a business user or a client or a program manager or the director or a VP, you will write queries, maybe directly or indirectly. You use some web application to write queries. You click on generate the report, it will generate the report. You see that report. In the background, it runs a query. It triggers a DQL. Forget about all this. What is table? You are able to understand this terminology, what I mentioned. Table is a container of data in a form of rows and columns with some structure defined. The table is created with some structure defined, which can be loaded with the data in a form of rows and columns, which can be queried later back for our analysis purpose by using DQL. So a table we have to deal means we need to invoke DDL, DML and DQL. Then only a complete table we can leverage. Without a hit on DDL, DML and DQL, I can't leverage a table. I can't realize what is a table is all about. Okay, so now if we see the fundamental behind it, right? We see the fundamental behind this. We got a table created under a database of this sheet. This database name is assignment SFM flowchart. And under the sheet, I created 3 tables. One table is sheet 1, sheet 2, table 3. This is the third table I created. Inside the table, I inserted or I created the 2 columns with the structure defined. And in this table, I inserted 2 rows. Now I'm going to query this data. I'm going to filter the data, whatever I needed. I wanted to see only Inceptez. I'm applying a filter. I'm writing a filter class, where class in the query. I'm going to only see the name. I'm not going to see the ID. I can do all sort of operation. I can filter at the column level, row level, or both. I applied both filters, column level filter, row level filter. Where class or select statement I wrote. That is what we are doing here in writing the SQL query. I wrote this select ID from this table where ID is equal to 1 like this. If I write the same thing, I'm doing here also. Same thing I'm doing here also. You can see I'm going to do the same thing here. Hey, choose only ID column. Hide name column. Hide name column. Choose only ID column. But I wanted only this row to be chosen. So help me achieve a filter of only the row number 1. Like this I'm doing here. The same thing, if I write it as a SQL query, I'll write it as select ID from the table name where ID equal to 1. The same thing I'm just manually going and clicking right in the Excel sheet. The same thing I can do it in the table by writing SQL query. What is SQL query? You are slowly understanding. What is the English I'm writing here? You are able to understand. In a layman perspective, this is what. Okay. So now let's go back. What are the other components we have? Field and or a column. We can call this as a field or a column. Agree? This can be a field or a column. You can name it in any way that you want. This is field number 1, column number 1, column number 2. Field number 1, field number 2. Anything you can name it as. Doesn't matter. Okay. Field or a column is nothing but an attribute contains the part of table data and identified vertically. The column is nothing but a attribute or a field or a column. Attribute means I will identify the column with the name of a name or a name. It is a name or an attribute that contains some portion of content of the table. 10 columns forms a table. One column contains one value, what I wanted to store. So the column is a name or an attribute contains the part of a table data identified vertically. We'll go and see the column vertically, the row horizontally. So if we see here, we are projecting the column vertically. We are projecting the row horizontally. Agree? If you click here, it is projecting vertically. If you click here, project horizontally. The meeting point is nothing but the data what I expect. So the column can be identified vertically, the row can be identified horizontally. Column will help us identify the given attribute, given name, given portion of data, part of data from the table, not entire data. I want to see only a column value, only the name of the customers I want to see. That is column. Following meeting, data type. The property, it's one of the important property defined for a column. The property defined for a given column based on the type of values stored in that given column. That is called data type. The type of data that I'm going to store in a given column will be identified by using the data type. Data type will help us identify what type of data we are going to store in a given column. So the data type can be of different type. We learn data type concept everywhere in our learning. Everywhere we are going to learn the data type concept. Some examples of data type is maybe what are the data types, guys? Integer, long, short. In the number type itself, we have multiple types. In the string type, we have, or in the number type itself, we have decimal, float, double. Everything has its uniqueness, significance. I'm not going in depth into it. What is what? I'm not going. For example, to store a maybe like the customer ID, I'll use integer. To store the transaction number, I'll store long. I'll use long. To store the age of a customer, I'll use short. To store the maybe like the amount the customer have spent for purchasing a product, I'll use float. If I'm going to store the product the customer have purchased from a grocery shop, I'll store the data in a float. But if a customer is purchasing a product in a share market for lakhs and lakhs of amount, then I'll store that in a double data type. Like this, the data type will be used to define the property for a given column based on the type of values that I'm going to store, the data that I'm going to store, which includes number type, string, character type, number type, character type, date type, Boolean type, right? And then timestamp type, some special type. Like this, lot of data types are available. Null type, not null type, like this and all we have available. But we are not dealing about all the data types. Just I'm giving you a high level idea of character data type, varchar data type. What is the difference between? So these are all the categories. Integer, long and short are one category of data type. This will be helping you to store the whole numbers, whole values. 1, 10, 100, 10,000, 25,000, 1 lakh, 1 million, 10 million, 20 million. I'll be storing in a form of integer, long or short. Depends upon the size. Short will be very smaller. Int will be next bigger. What is the size? Every database has their own size. Some database will say in the short I will be allowing you to store up to 3 character length, maximum of 3 bytes length. In some database they will say 4 bytes length, or some database will say 2 bytes length I'll allow you to store. Like this, it varies basically. Integer, I'll allow you to store maybe up to maybe like 30 million values. Long will say I'll allow you to store even billion, trillion records, trillion numbers into your column value. Like this, they will be allowing us to store based on the column and the size I can define. Certain places I can define the size. Certain data types I can't define the size. So in the decimal, I will be defining the size decimal of 10, 2. What is the scale? What is the precision? What is scale and what is precision? We'll learn more in detail later because we don't find time to learn all this and all right away. We'll learn about it later. Scale and the precision means what is the whole value, what is the decimal value. How to calculate this number, I'll talk about it later. But for now, what is the whole value, decimal value? Up to 10 digits, I'm going to have the overall, in which two digits are decimal, 2 digits are dot value. So I'm going to store 1 lakh dot 55 paisa, 10,222 rupees, 55 paisa. I'm going to store like that in this decimal type. Float and double is also related to that, but float and double has some fixed maximum capacity. We don't define the size in the float and double. Float will support to a certain extent of 32, 11 or whatever the size, depends upon the database, it varies. We don't have to remember that number and all. We can use that number at the time when we go and store or create the table structure. Character data type, varchar data type. See, I'm not going in depth of all these guys because we'll spend some time in a later point of time to discuss about all this later also. But just I'm giving a high level overview. Character represents what? It's a fixed size data type. That means what? If I'm going to say, hey, I'm creating a character data type of a column called state code. I'm going to define the data type of this is char of 2 or char of 3. It will allocate 3 bytes of space here for me to store some data. It will allocate 3 bytes in all these places by default. In this column, totally it will allocate 3 bytes of space. It will allocate the 3 bytes of space. So what I will do, in the 3 bytes, I'll go and store New York Central, New York City, or I'll be mentioning something called California. Some places I'm going to mention as New Jersey. I don't have 3 characters to mention New Jersey. So what will happen? The one space will be appended to fulfill this size, because the size of this is going to be, length of this is supposed to be how much? A fixed size of 3. The length of this column has to be a fixed size of 3. But whereas if I create the same state code, in this case and all, I don't create it as char of 3. I will create it as varchar of 3. What varchar says? Variable character. That means it won't pre-allocate a space and all. How much I'm going to store? It will allocate the space accordingly. It will store only whatever I occupy. It won't unnecessarily append a space here. So what is the length of these columns and all? It is going to occupy only 2 characters, that is varchar. Finding the difference between char and varchar. If I give a char here of 100, when creating this table, this name column will be allocated with 100 spaces pre-built. I am going to fill with 5 characters, balance 95 space will be wasted. It will store the data not like Irfan. It will store with the additional 95 spaces added in the data. If I define this as char means, varchar means whatever the size I am really occupying, it will only take that much size to occupy in that given column. One of the important data type to know in a database table. With me or not? I did not give a complete numbers and all here. Just gave a high level idea. We did not go with date. We did not go with all other data types and all. Date is one of the data type. Timestamp is another data type. Char is used if you are very much fixed about what data you are going to store. Like the better example is the state code. Better example is the gender. Better example is marital status. Married or unmarried, M or U, M or F, or maybe like anything that I'm having in a fixed way. Pin code, yes. YRN, flag, you can set all those and all in a char. Varchar, one person name could be 5 characters, another person name can be 30 characters. So I'll define the size up to whatever maximum space I am going to occupy for a name. I'll store in that way. So char of some character I can mention. If you don't occupy that fully, then you have to use some function to trim the unwanted space. You have to use some function called trim to trim that unwanted space and all. If you use character. If you use varchar, you don't have to worry on trimming and all. Automatically the size of the column will be expanded or contracted as per how much you are going to store the data. We are reserving 100 varchar space, but you are not going to use all the 100. That is applicable in the case of varchar data type. Date is a data type that is going to help you store the data in a format of a given date format of year, month, and day. YYYY -mm -dd. So I can create a table by mentioning the date of join as date data type. Date data type. I'm going to create a table. You can go and see, or you can go and load the data into the table by mentioning the current date. current date is a function we have available. This is a built-in function. We are going to deal about this and all more in detail later. Built-in function. I'm going to say what I store the data into this table with the additional column, whatever I mentioned. Store the data with the current date added there. So how it is storing the data into the table? I did a DML operation. Now I'm doing a DQL operation. It is showing the date is in a format of year, month, and day. 10 bytes it occupied. Or I can add date of join and time of entry, time of login. I'm going to store as timestamp. So it will go and store the date and the timestamp. So I'll be storing current timestamp. You can see year, month, and day, space, hour, minute, and second separated by colon. Minimum this data types, if you are aware of, you can work in most of the databases, most of the SQL environments. Date and timestamp. These four are the different categories you can consider this. We have a couple of other categories. We will learn it subsequently. Let's not worry today on this. Okay. And in detail about this, we will be learning subsequently as well. Let's not worry too much of this. Okay. We are going to apply this one only in our entire learning. So I don't want to spend this time for learning this part more in detail. I wanted to learn this along with the entire broader people, because I know like not everybody has a good understanding of all these types and all. Record or row. Okay. What is a row or a record? What is a row or a record? Record is a entire horizontal column values or a connected column values. So the name or attribute that contains the part of a table data identified vertically, right? The group of or the identifier that help us propagate across the columns, right? Identified horizontally. What is a row? Row is a collection of columns. You can very simply say. Row is a collection of columns identified horizontally, we can simply say. But a row can help you propagate across multiple columns, right? Across multiple columns, we can propagate via a row. I'm going to say, guys, I'm going to access a row number 1 identified by an identifier. I'm going to identify the row ID as 1. I'm going to use a row ID called 1. So we can say here, I got the first row selected, second row selected. You can use some identifier to identify the row. Either the column value you can use as an identifier or some dummy value we have to identify a row. That is a different story. We'll learn about it subsequently. But an identifier that helps you to identify all the columns horizontally will help you connect all the columns. Yeah, a column will help you only see a given column. A row will help you group all the columns and show the given row of result. So very simply say, row is nothing but row or a record is nothing but the collection of the columns in a given table identified horizontally. I can say like that very easily for your reference. Collection of column values identified horizontally with some identifier. Basically, we propagate on multiple columns with the help of a row. We'll see the data in this angle to see what is the column 1, column 2, column 3 value of a given row. Okay, that is where I mentioned this term, but let us remove this term, make it simple. Make it simple. right? Are you guys are with me in this? What is a row? Okay, fine. What is a view? I'm not interested in this right now because view is a very important component, but it requires a different understanding. First, we need to know about what is a table, even more better. What's the DDL, DML, DQL, and all. We have to do some practice on that to get some idea. Then we can go to the view. We'll talk about it later. But view is nothing but I'll write the definition of the view right now. We'll again come back to the view part. I'm going to cover the view part with you guys, but we'll just come back to the view part later. View is nothing but a stored query. View is nothing but a stored query. So rather than we write a query manually like this, people used to have a lot of debates on view. Interview opportunities are huge in view. But I'm going to say what I hate writing these queries regularly. Let me store this query somewhere in our database environment as an object. This database contains how many objects? Our aspirant DB contains how many objects right now? Only 3 tables as an object. But I'm going to create one more object in the name of a view. I'm going to store this query in the name of a view. So create view, something called aspirants DB dot W45 TBL2 underscore VW view as this query I'm writing. So I don't want you guys to write this query again and again by remembering how to write this SQL and all. I'm just going to say, guys, I created a view to store this query in a database. In our database, I got this query stored in the name of a view. You guys go on going forward, don't write this query and all unnecessarily. Write a select on top of this view. Internally, what it will fire in the background. If you run this query on top of the view, if you run a select star, it will internally fire this query only, because in the place of this view, I got this query only stored in the background. In the name of this view, I got this query only stored in the background. Tricky to understand, but very important. Lot of people who is going for database interview will be asked with this question, agree or not? What is the difference between table and the view? Does view stores data? What is view is all about? What is the benefits of going with view? Like lot of questions on the view you will be getting, obviously, no doubt on that. So we have to learn about view more in detail later, but for now it's a stored query. Very simply, you consider view is also a database object. It is a stored query. Guys, with me on this or not? Take it very lightly. View is a stored query. View is a stored query. Rather than you sit and type the query every time, you store it somewhere. Just to select star from view name, it will run the query in the background. You don't have to write that query. Remember how to write the query and all. You don't have to remember. There are other objects in the databases. Procedures we will be creating later. Functions we will be creating later. Indexes we don't use heavily in, at least in our databases. But I'm just putting a right through for this and all for now. We don't do it in our database at least. But in our big data lake, lakehouse and all, we create procedures and functions also. That we do later days. Leave it for now. What are all the components of the database? You got some idea, guys. The components of databases. This image now you go and see. This image shows what? This image shows I am running in a database server. My name is a database. The database comprised of schemas and databases. The database server comprised of schemas and databases. The schemas and databases contains tables. Table contains fields or columns. The columns are defined with some data types. The data can be loaded into the table in the form of rows with column values implied in it. And the tables can be queried by using the DQL statements. And that query can be stored in the form of view. This is what the connector learning of what we did so far. View does not accept parameter. If you want to accept parameter, you have to use functions. You have to use functions. Okay, but that is a great need of the market. But view does not accept parameters. That is a need of the or what we have. Even I was expecting a view can use parameters, means we can achieve a lot like this. In my current project, I have a need, but I'm not able to get that achieved. Okay, I mean, I can use a function to go and maybe like pass the parameter to the view. That I can do. Or you apply a filter that will act like a parameter. But literally, we can't pass a parameter to the view. For example, I got a view stored here. This view I'm going to query like this, right? I'm going to query this view. Select star from this view, where id equal to 1 I'm writing. This id equal to 1 is a parameter I'm passing. You can pass a filter condition. That can act like a parameter, but you can't pass other parameters. Say, in the view I dynamically create without the table mentioned. You pass the table dynamically, the view has to query the data from the given table. That is not possible. Following me, Tamil? The view will have the query whatever you stored literally. You can't change that. Okay, fine. But on top of the view, whatever it is producing me the result, I can go and filter the data. It will be behaving like a parameter you pass, but not literally, not really. You are feeling like, hey, I'm passing a parameter called id equal to 1, and this view will return me only id equal to 1 value. But actually speaking, the view is bringing all the data. Then we are applying one more filter on top of that. We are not passing parameters to the view internally. Okay, let it be. Leave it. Database also will show the whole query. Then what is the use of view? Database also will show the whole query, right? No, database will not store query, right, Suganya? Database will store only the tables. The tables are stored, not the query. I wrote this query, where it is stored. If I close this window, this query will not be stored anywhere. Again, I have to retype this. I lose my query. But if I close this window even, I go to a new window, I don't have to write the query again. I'll just write the query on top of the view. This will fetch the data from the table which contains only one, which has two records actually, but it is filtering and bringing only one record because I'm querying the view. The view is going to run a query on the base table and bring the data. So I'm using the stored query rather than I write a query of select star from table name where id equal to 1. I'm writing a query on the view. The view is running the query in the background and pulling the data from the actual table and showing me the intended result to me. With me, Suganya, you got the idea what I'm speaking? Right? Database is a container of tables, right? Not the query. Query means what? I'm writing this query means this is a query. The table will be stored by the database. The data of the table will be stored by the database. But the filtered data will not be stored by the database. Right? The view I'm creating to say what? Hey, you help me not write the filter manually. You get it stored in your name, some name, view name or something I'm creating. And help me write the query on top of it. Like this I can tell. Okay. View is a tricky concept. View has lot of questions. But I told, right, I'm not interested in talking about view much of this. The reason behind, I want to cover something more fundamental than the view. We don't have a clarity on table itself. First, I want to give you a clarity on tables, DDLs, DMLs, DQLs and all. Then only you can learn view more in detail. But since the components of database comprised of all this, I'm just touch basing on them. Keep it in that way in your mind, guys, for now. We can have multiple views. We have views created as materialized view, as a normal view. We can refresh the views. We have a lot of options in views, right? Lot of things to learn in views, but let's not worry on all those. Okay, complex view, simple view, lot of concepts are there, but I'm not going into that level of concepts and all. Not needed even for even a data engineer. Since I learned it in my initial days and all these concepts. Literally speaking, guys, I did not prepare anything on this and all. I'm just taking you directly from the knowledge what I gathered on the year 2003. 2003 what I gathered, 2003, 2004 what I learned. I'm just conveying all this to you. And I created a mind map in such a way like that. Because I was in a situation. I need to get a job. I need to get an opportunity in IT. I am in that situation. I need to get, no other chance for me, right? I wanted to make my parents feel more, maybe like happy and more, what to say, like they have to, show themselves like they are having his their son earning or into IT, to prove everyone like, yes, we are also a kind of maybe like people who is growing like you guys. Like this, I wanted to show that, I want to prove that. That is the attitude I had on learning this DB. So you ask me anything in this DB, I can answer you. Any database, any concept in DB, you ask me. What is table mutation, you ask me. The database administrator question, you ask me, I can answer you. But I'm not going in all those levels with you guys. I was a bit hesitating to take this DB session, mainly because if you allow me, I'll take this DB session for 1 month to you guys, but I don't want to do that. I want to have 2 sessions on this DB, because we are going to spend almost over 6 months in the DB learning only, but in a more better way. We'll be learning about these views. Even in our learning, in a later point of time, if you search and all, you can find, I'll be talking about views. You see here, how many places we are dealing about views in our learning. Agree, guys? So let's not worry about it. This is the first time we are understanding what is view. We are going to learn this only throughout our learning journey. How many places you see? I'm using the terms called view. Okay, fine guys, let's not worry. View is like a saved search. We can select that to open the search without applying all the filters again. It's not like view is a saved search alone. View is a saved query. A query can have search, a query can have aggregation function, grouping function, limiting function, join conditions, set functions, right? Anything it can have. It is not only a condition I'm going to write as a filter and store it somewhere. You can write any such kind of query and store it in the name of view. So view is a stored query. Rather than you write the query again and again, you store it in a name and call that view anytime. That will go and pull the data of the underlying query. I always find this case. What you know, whenever I say don't worry on this case, we discuss in detail, you will be worrying more on that one only. Don't worry. Just worry on the fundamental things. We are learning only foundation and fundamental. Okay. Let's not worry about it. Let's go into the fundamental. Okay. However, I'll be covering. Don't worry. Okay, guys. You got some idea about the components of DB, components of database. You got some idea. What is database schema? Database or schema? Tables, fields or columns, data types, rows. What is views? Maybe very basically stored query. We are happy. Now let's go into. I'll extend the session till 8:15, guys. But I wanted you to really start our activity right now. Okay, let's go and do the DDL minimum at least today. DDL is a priority 2 item, data definition language. In the data definition language, what we are going to do? We are going to create a table, create a database, drop a database or schema. Did we do this? Did we do this literally? Just for your reference purpose, I'll put that statement here. I'll put the statement here, guys. Whatever we did, I'll put the statement here. Create schema, schema name. Create database, database name. Create schema or create database you can use. So I wanted you guys to try this now. Did you guys connected to our cloud database, guys? How to connect? Do you want to understand? Let me show you guys. Okay, you guys can do along with me. So you get some time to practice on these things and all. Okay, until we go for the next session on this. Okay, so how to create a database or a schema? You use any of this syntax. I don't bother. How do you go and connect to the database what I have created? I wanted you all to create a database in my cloud database server with your name. You got to create one database called Mohan Raj DB, Lokesh DB, Bharat DB, Cynthia DB, Dhanalakshmi DB. Can you create? How? How you are going to create? We are going to see here. I'm going to show you guys your name here. Somebody have created class DB, low key test DB. Lokesh have already created, it seems. Test DB, somebody have created, it seems, already. But how do you connect to the database? How those people have connected to the database? This DB and all I did not create it, at least. How did they create this DB? They went and opened a tool, whatever I asked them to install. They installed the tool in their computer, just in their Windows computer, and it may ask you to install Java if it is not present in your computer. Anybody got that question? Install Java to use this software. If you already have Java, it won't ask. Otherwise, it will ask. Okay, fine. No worries. All of you guys install this software in your VM, guys. Anybody having any problem in installing that software? Okay. Now you are going to open that software. What is the name of the software? Workbench. MySQL Workbench. I'm opening this Workbench software in my computer, like how I open a normal software in every computer. I'm going to the database. I'm going to create a database. I'm going to either use the existing database that I have, or I'm going to create a new database. I'm going to the manage connection to create a new database. That is what I have given in your whatever the documents and all. So I'm going to log into a new database. What is the name of the database? I'm creating for my own purpose. For example, Jaya Bharati. Jaya Bharati is the name of the database connection name I'm creating. For Jaya Bharati's purpose, he is creating one connection name like this. What is the IP address Jaya Bharati has to connect to bring the database into the cloud environment of Irfan or of Inceptez? He have to get this IP address from me. I have to give this IP address to him by some way as an administrator of the database. So Irfan is an administrator who created and maintained the Inceptez database in the GCP cloud platform. Irfan is giving this IP address, the username. Maybe I may create one user called Jaya Bharati and give it to him. But in our case, we are having one common user. We are all belonging to the same team, Inceptez learning team. So we are using a common user called Inceptez. So we are using Inceptez. Then I'm going to store the password in the vault, so no one else should know this password. But I typed Inceptez as my password and stored in the vault. Vault will have the password in an encrypted fashion. No one else can open this vault and see. If I'm keeping this computer and giving to somebody else and go, they should not see my password. What is the default database? When I open the connection, it has to land. I'm mentioning the core banking or whatever the database that we already have in place. Core banking, which is a default database, it is showing, right? You see, for this connection. But aspirant DB is the default database for this connection, let's assume. Then I'm going to say what? Aspirant DB. Aspirant DB is the database I'm going to connect by default. I'm going to test the connection. Connection is tested successfully. Great. Now I'm going to say close this. The Jaya Bharati connection got created and I'm closing this connection. Now I'm going to the database, connect to the database called Jaya Bharati. This is already in place. I don't have to do anything. Just click OK. The database SQL editor, Workbench editor is open. So rather than I ask you to go to the Chrome and connect to the Google Cloud account and all, I don't want to. I'm not asking you to create an account. I'm not asking you anything to do in the cloud. I'm asking you to leverage my cloud database by using some desktop tool. So you are doing what now? You are going and connecting to my database from your desktop by using a desktop tool, by mentioning the IP address, username, password, and everything. Now the database running in the remote cloud is going to be in your hand. You are sitting in Chennai, Hyderabad, Mumbai, Delhi, Kolkata, and you are querying the database running in US data center, like Putty, correct? Like Putty. Putty we used to connect to the Linux server. This DB workbench we are using to connect with the cloud database server. We are using Chrome to connect with the Google server by typing google.com. We are going to the Gmail box to connect with the Gmail server. Agree? The same thing we are doing here. The same thing we are doing here. Okay? I hope you are getting a better clarity on this. Now, I entered into the database. I'm going to open a new terminal even if I want. Now I'm going to run a query like show databases. It's showing me what all the databases we have available. Oh, it is showing this many number of people have created the databases. I'm going to run this show database query every time to see how many number of records are returned. 20 people so far have created databases. Bharat have created, Lokesh have created, Madhumita have created, Mohan Raj have created, Subhash have created, Suganya, Vandana. I wanted to see all of you create a database by mentioning create database, database name, Irfan DB. Like this, I wanted all of you to create one database using create database statement or create schema. Right? I created a database. Now, the number of databases increased to 21 database. How many database now I got? 21 database I got now. You can see here the result of 21 databases it is showing. 21 databases. I want to see more databases. You guys are creating. Take your time to create. Still I'm finding, now I find 26 databases. Great. You guys are going and knowing how to create a database in the database server in the GCP Cloud SQL database server. You know how to create a database using this syntax. Create database, database name. Okay. Okay. What it does is it created something like this in the background. In the database server, it created one rack for you, one drawer for you, one cupboard for you to keep your folders and files, to keep your tables. Now we got an empty drawer. Everybody have created one empty drawer. Right? This is a part of DDL. The DDL comprised of creating of database, dropping of database. That is also a activity only we are performing. So we created a database now. I want to drop the database. Drop database. Maybe Irfan DB. I wanted to drop my database. This is a DDL. I got my database dropped. If you see, I don't see my database called Irfan DB going forward. I'm not finding Irfan DB. It is lost. I got it lost. Done. I got 31 so far databases created in our environment. I'm expecting more to be created by you guys. Please try that. Connect it to my cloud database and go and create your tables over there and all. Next we'll do that. So you understand under the DDL data definition language, we can do database creation and database dropping of database. Now I want to create a table. Creating of database is one case, means creating of table is the next activity we are going to perform. How to create a table? Let's create some sample table under the database in aspirants DB. So create table. I'll give you guys the syntax, right? Create table, table name. The name of the table is my name, Irfan TBL. I want to store my name, or I want to store my ID. I want to store my name. I want to store my address and date of birth. So create table Irfan TBL of ID integer, name, varchar of 100, because my name can be extended up to 100 characters. I want to store my family information or anything I want to store. I want to store my aspirants information. So ID, name, age, age as maybe like a short int I can create, or let it be age as integer I'm creating. Then date of birth, date I'm creating. First I'm creating a table like this. How to create a table? I can ping you all this in our this thing for now, for a while now. Or what you do, you guys can go and do this activity also. You guys go and download the sheet that I have provided to you here. In this sheet we have the DDL and DML operations to perform initially for building our data set. We need to have some data set created in our database. So you can go and take this and create a database if not exist, or create a database if exist. If not exist, delete the database if not exist, create a database, show databases. Maybe use IZ learning alone is not working in the cloud platform. At least here we can able to use this. Show tables we are using to see the list of tables I created inside the database. Now you are creating a table like this. You can download this and create a table inside your database also. You mention this database name as your database name and run this script to create two tables called departments and employees. You can copy this and practice here, or place here, paste here, guys. You can open a new terminal, paste it here. I'm going to do what? Drop the database called IZ learning if already exists. Create a database called IZ learning. Show the databases and all whatever I have. Use IZ learning, go to IZ learning. Show the tables already present in IZ learning. I'm going to do all these activities. Create a database called IZ learning. Maybe you just mention your database name. Don't use IZ learning as your database name. Because I'm also dropping the database, you also drop the database, we lose our data. If the database already exists, you drop. Right? Like rm-f we are using. rm-f option we use in Linux, right? If the directory or the file is already exists, then you drop. Otherwise, don't throw me unnecessary error, I'm telling. The database already exists, drop. Then create a database. Then show whatever the databases we have in our environment. We have in our remote database server, 37 databases we have. Not everybody were able to create the database, or they are not working on it. It's okay. But try practice. I gave you a database, try create a database. Use the query that I have shared in our drive even. Otherwise, if you are not using the query that I'm sharing in the chat, use the query that I shared in the drive. Change the database name alone. IZ learning underscore your name you give. By the way, you create a database. I'm not stopping you creating enormous databases in my cloud database server. You can create it. It's for you to create. Okay. Show databases. Use IZ learning. I'm going to the particular database called IZ learning. I'm double clicking on that folder and going inside that. Show the tables in it, whatever is present. No tables are present in the IZ learning right now. Now I'm going to use create table department. The department table, I'm going to create a table called department with how many columns? 4 columns. What is the data type of each and every column? Integer of 4, varchar of 30, integer of 6, integer of 4. Then I'm creating one more table. What is this not null and all? We will deal. Wait for a while. What is the constraint and all? We will deal. But for now, I'm creating a table called departments table. I'm creating a table called employees table. So the best way to learn the concept of SQL is using employees and department. That is the best way to learn SQL queries. The database tables that we use, employees and departments, will give you a best way of learning the database queries. That's the reason I'm using this simple, whatever the database tables of employees and departments provided to us by Oracle. Oracle have given this database tables, data types and all for us to play around. Okay, we got the tables created, guys. We did so far what activity? DDL activity. You guys can go and do the same activity. Only caveat is, please change this name to some other name. To your name, you append your name here. Underscore your name with you. Let me see how many of you guys have created IZ learning database. IZ learning How many of you guys have created? Let me check. So you just click on this execute the selected portion of the script or execute everything. Right? Execute the selected portion of the script. So it is showing how many databases overall got created is 39 databases. Everybody have created it in the name of your name. That is okay. Anything, anyway you create, I don't stop you. But one database I created in the name called IZ Learning. You can see IZ Learning also is also kept over here. Okay. One thing is, I'm going to share this recording for all of you guys to revisit, to use it. Okay, I'll be sharing the recording for all of you. I'm going to finish in another 4 minutes. We'll close it. The DDL path is kept in our drive only. So guys, anytime you don't have to ask me the drive path, it is there in our WhatsApp description. Go and get the drive path, go to the SQL data warehouse, see the context, you'll be understanding where what will be kept. The name itself will tell. The softwares are kept here. The virtual machine PDF documents that I'm sharing will be kept here. The SQL data warehouse related contents will be kept here. For now, I placed this PPT, what we use today. I'm going to place the modified PPT. I have the installation document and I have the practice query of only DDL and DML. Okay, Mohan Raj. This is the link, but I wanted you to get it from the WhatsApp description. You don't have to depend on, always have that as a practice case. This WhatsApp description with this link will be kept forever throughout our lifetime. Throughout our lifetime, this will be kept, this WhatsApp will be having this link. You can use it anytime. Okay, fine. How to see the available databases, tables, views in the sidebar. Okay, that is the Explorer, what you have to configure. We'll configure that. No worries, Madhumati. Okay, I wanted you to use some queries to see that for now, rather than using the Explorer. Okay, that's the reason. We can configure, but I wanted you to use the queries to see the databases, tables, and all the information, including the structure of the table and everything. You have to practice in that way. We can't always depend on some tool to show that and all easily. So we have to know about how to write some scripts or queries to quickly do some operation. Okay, that's the reason. Keep it aside. Click on the schemas next to the administration tab, view the DBs and tables. Okay, right. That is okay, but however, I don't want it to go in that way right now. Can you please tell me the difference between database and schema? Right? Tilak, the difference between maybe like what it's a name denoted for the same concept. Different name we are using for representing the same concept. Both are same. Both are literally same. Okay, Tilak. Database and schema are same. Both are same. Don't see it as different. That's where I put database is equal to schema is equal to data set is equal to catalog. Database is equal to schema. Schema can be called as catalog in some databases. Catalog databases or schema will be called as data set in some databases. Everything is same. People use different names in different places. We can do all those activities. We can change, but database level changes if you want to do. Right? Alter database name, change, modify. Like this, you have to use the syntaxes to do that. But it is okay. It is okay. Database name will not be so easily changed because it is being distributed to everyone across the org. But we may change the tables inside the database more frequently. Suganya. Okay. So in the form of SQL query, are we using brackets? Can you let me know the format is defined? How the format is defined? Okay. How the format of the SQL query is defined? If you want to go to that level, let us see that. See, basically, I'll be creating a table like this. Create table name. That is the syntax we have to use. Like you are asking about the format of how to write Janani. I have mentioned that one only in this sheet in the last but few pages, especially MySQL cheat sheet I created. Click on this MySQL cheat sheet. You can find how to create a table. The syntax of it. To register the syntax only you have to do. You have to do an activity of registering the syntax. So create table, table name with open bracket, closed bracket, followed by semicolon. You have to mention the column name, data type. Forget about the constraints. Constraints is optional. Example, create a table with all these columns with additional options added. Lot of options we can add. Default, null, unique constraint, primary key constraint, foreign key constraint. Like lot of things we can add while creating a table in a proper RDBMS platform. But in a regular environment where even we are going to work in BigQuery or Hive or Spark or anywhere, we don't create a table with all these features applied. We will not have constraints and all there in the big data based database environments. The constraints are not applied in the big data based environment. So I'm not bothering much about this constraint concept and all right now. We are only creating a mere table for an understanding purpose. So create table, table name of open and close bracket you can put and say the column 1 data type, column 2 data type. You have to register this in your mind. Create table, table name, bracket open and close, column name, data type, comma, column name, data type. This is the structure of writing the SQL query for creating a table. I'll come back to where we are this. Very important, right? Where we are. We are in a learning of what is DDL. What is DDL? In the DDL, we can do data definition. We can create, drop, rename, alter, everything we can do. But fundamentally, create and drop we mostly do. I want to create a table. How to create a table? Create table, table name of column name, data type. That is the syntax for creating the table. I want to modify the table. Alter table, table name, right? Add column name. I created only up to date of birth. I want to create one more column name. So I'm going to a database called use Irfan DB or use aspirant DB. Somewhere I'm going and I'm creating a table. This table I want to add a column additionally. Alter table, table name, add the column name. What column name I want to add? I want to add the city as varchar of 100. This is even a DDL operation we perform. So I'm creating a database. I'm going to a database called aspirants DB, creating a table and altering the table. I'm going to the aspirants DB database. I'm going to creating one table in the aspirants DB. Right? Aspirants DB, I'm going into a table. Then I'm going to perform an operation of altering the table. So I want to see the structure of the table. You can go and see it in the menu, or I'm going to do what? I'm going to say describe table name. So it will show me what are all the structure you have in the table. It is telling what? Irfan, you have ID column, name column, age and date of birth column with all these characteristics. It supports null also. You can store null value, but what is null we have to still learn. So describe table name. Then alter the table, add a column. After adding the column, I'm going to describe the table name. It is showing me the table got additional column got added as city. How to add a column to a table? I wanted to alter the table, table name, drop the column name. What is the name of the column I want to drop? The column called date of birth I want to drop. So this is the syntax for dropping a column. This is also a DDL. I'm adding a column, dropping a column. After I dropped, I am not finding date of birth is added. Date of birth is removed from the table. Like this, we can write multiple alter table statement to create, add a column, remove a column. To remove multiple columns, we will give alter table, table name, drop column, Something else also. Name. Drop column age. Drop column name. Like this. I can drop multiple columns even. So I dropped multiple columns in one shot even. The name and the age I dropped even. You can do that. You can do that. I want to drop the table itself even. What I'll do? Drop table, table name. What does describe will do? Describe will show the structure of the table. Describe will show the structure of the table. The table contains how many columns, data type, everything it will show. So you are seeing here in my cloud environment, I'm having a table, right? This table, this database contains a table. If I expand this table, it is showing the structure, right? How many columns it contains? What is the data type of this column? Integer, string. Rather than I click here and see all this, I'll just write describe. Describe the structure of the table I'm writing. Right? Only by practicing you'll get all these guys. Okay, but however, I'm dropping the table itself. I'm recreating the table from scratch. Altering, adding a column, dropping a column, renaming a table. I'm having one table created already. What our friend was asking. Alter table, table name, rename to some other table name. Rather than Irfan table, let me rename it as Inceptez table. Now Irfan table is no more exist. The table got renamed to Inceptez table. If I say describe, it will say sorry Irfan, there is no Irfan table available. It is throwing an error. Then the table is renamed to what? Inceptez table. Inceptez table. Okay, how frequent we use this syntaxes? Right? How frequent we use this syntaxes? Very minimally. And who will use this syntaxes? The most of these syntaxes, create database, create tables, everything will be used by whom? Will be used by our administrators. These are all mostly by administrators they will use. We request the administrator, they will execute this most of the time. Or we also do, I'm not telling we don't do at all and all, but administrators will mostly do this activity. So create and modify the table structure. I know like we are on top of the hour, right? I don't want you guys to extend more time here because morning also you attended the session, right? However, right? I hope you got some understanding here on the DDLs. You try this out. Try these fundamental things out. Drop or rename the table from the schema. Drop table, table name. Drop table, table name. Load the data into the table. Insert into table name values of. So you just practice on these commands or queries, whatever I have given, guys. What is constraint and all we'll talk in the next session, right? Insert into the table values. Just load the data into these tables by having these queries executed. Copy these queries and execute in your environment to understand how to create a table, how to create a database, how to load the data to the table by writing an insert statement. For now, you just try to learn this part. However, we learn this part in the name of other databases subsequently, Hive or Spark, SQL, or every other databases. But here we are learning the jargons of it, the fundamentals of it. Yes, I already you have in our drive one set of query. I have given only a fundamental DDL, DML data generation query. I'll be sharing you a lot of other queries subsequently. But this sheet I'll be, or this slide, whatever we covered so far, I'll be uploading in our drive right away. So you at least try till this part. DDL part. In the DDL part, we only covered how to create databases, create tables, drop tables, create tables, modify tables, drop tables, some fundamental thing we covered. How to create a table from another table. Already we have one table. I want to copy the data of the table to another table. I know how to rename the table. Alter table, table name, rename to some other table name. I have one table already available. I want to copy the data to another table. I use some query called CTAS query. Like this and all, we have some interesting thing to see here. We'll see that and all subsequently. We load some data, we play around with the data to a basic extent of understanding few things. How to truncate the data from the table, how to delete only the data from the table, not deleting the table itself. This and all I'll go in a fundamental way by showing some related concepts. But up to here, you guys practice, and we'll go to DML next. DML is insert, update, delete. How to insert single row with few columns and all columns. How to load multiple rows into a table in one shot. How to load the data from another table to this table, maybe whatever I mentioned here. This is how to create a table from another table. Under DDL it will come. How to load the data from another table to this table, that will be happen with the DML. Like we learn lot of interesting factors in the subsequent week, guys. Okay, I will be having one more session with you guys. That will go for almost 3.5 hours of solid time to cover the DDL, DML. TCL and DCL is very simple concept to learn. Very short time it will take. But the DQL is very important, where we are going to concentrate more, where we are going to learn lot of things. The DDL, DML, you can least bother even. Right? We are going to learn DQL very importantly. This is very important primarily. Then subsequently, we are going to learn the some of the built-in functions, case statements, SQL subqueries, common table expressions we use. This and all we are going to learn. And what I will do, I'll cover these things in one more session to an extent of how much we can cover. Then I'll take you guys in our regular session itself. One day or one session or half session, I'll cover the rest of the part so everybody else also can see this, because these are all applicable for everyone. Who is already working in the SQL environment may not have a clear-cut idea of all this. But we learn these concepts only throughout with the pictorial representation and all. I have created a lot of pictorial representation for this to make you guys understand more efficient. Okay, this we will cover even in our further learning also subsequently. And MySQL cheat sheet, you refer this for the syntactical reference. Somebody was asking, right, Irfan, tell me what is a syntactical reference. You have everything here. I have mentioned here. Describe the table name, display the table structure. Somebody was asking, right, hey, Irfan, what is the describe means? Go and check this, you will get some idea as well, whatever I wrote. How to retrieve the data from a table by using specific columns. This is the document yesterday night, and I sit and created this. Late night, I created this document and all, attached to this document. For whichever the regular queries, some of the queries what you are supposed to know, I covered all this here. Creating the view even. Dropping of view. View is nothing but a virtual table based on a query. The stored query. Like this. You have all this. Maybe forget about this part, the last few part, which is more related to the transaction control. I mean, not data control, DCL, TCL, it will come under. Just to go through the part of what we are supposed to know very importantly. Okay, fine guys. Any question, team? Any question? I know like database can be learned for months even. I don't want you to spend months of learning. Just practice on whatever just I have given you. Right in this document, that minimum whatever I have given you, practice on this minimum. Minimum try to create a table. Understand what is a table, data type, column, how to describe a table, how to insert a row into a table, how to query the data from a table, what is a database means, what is the database architecture to an extent. I can connect to a remote database provided by Inceptez. Like this and all, you have a realization here for today. Okay. In the given hour, we can cover this much, right? Anybody don't understand anything specific, you let me know. Or ask in the group also. People are there to help you. Okay, guys. Any questions before we close today?
Fun.
Yes, Tanvi.
Yeah. So you explained about that book my show, like how the ticket is.
Correct.
So I just want to understand, like if I am trying to book a ticket and you are trying to book a ticket, you tried it first, but at the same time I can see that availability, right? So how
No, no, no.
is it?
See, I'm going to create a table. Okay. I'm going to create a table. See, basically, this is a not a very simple concept. What I told as an example. That example requires something called autonomous transaction. Autonomous transaction. We have some concept. This autonomous transaction will help us achieve the foolproof solution of what I'm asking, what I was telling. Who have Oracle database knowledge, guys? Who worked in Oracle databases? Over here. If you ask the people who worked in Oracle database even, they'll say, Irfan, I did not use autonomous transaction in my learning, in my office or in my so far experience. Muthu, have you used autonomous transaction in your organization or in your project or in your so far experience? Mayavan, he did not use. So that autonomous transaction and all is very maybe like rich or a very deeper concept in the database available to handle this kind of transaction isolation. If I ask you some concept of transaction isolation, something like serialized or uncommitted read, committed read, dirty read, this kind of concept and all. It comprises of all this, but for a basic understanding that and all is not needed. I was telling an example to make the people understand it easily, but to make you understand even this concept, let's assume I'm starting a transaction. Okay, start transaction. Okay, Tamim. In the start transaction, this is a user is starting a transaction. Tamim is starting a transaction to book a ticket in a book my show. Okay, so he's creating. I'm the book my show is creating one table. Create table. Book my show of the user ID and the name of the user or user ID and the seats and the time when this transaction is happening. We are creating one table, and in this table only I'm going to store all the customers who are all going to book the ticket. I'm going to have 50 tickets available. The customers will be displayed on the ticket information and all in the screen. Out of the 50 tickets, the customer is going to have the ticket of customer ID 1 have taken the seats of maybe like A1 row, A2 row, in the row A, A1, A2, A3, 3 tickets you have taken already. Okay, on a given timestamp. He chosen 3 tickets in the screen in the whatever I mean like in our mobile application. Now after he completed the ticket selection, he completed the ticket selection. He's not booking the ticket. He's leaving that GUI open as is. So when I write select star from table name, this table will hold the ticket information of the user. It will hold the ticket information. It will show the output of the tickets that is stored in the table. But when I say after some time, after 1 minute of time I'm giving to him to book the ticket, or 2 minutes of time I'm giving the time to book the ticket, the database is finding, okay, this ticket is not booked in 2 minutes or 3 minutes. There is a function is going to run. That function is going to say what? Rollback. This is transaction control language. When I do rollback of this transaction, the customer who booked the ticket will be lost if you go and see this. Okay, let me delete the data from this table or set commit equal to 0. I'm going to set the auto commit to off. Basically, automatically whatever the transaction you do, it will be automatically committed. That is what the data control language or data transaction control language will do by default. Auto commit will be set to 0 by default. I mean, it will be set to 1 by default. I'm setting it to 0. Okay, let us do this once again. The iteration of dropping this table. Okay, I'm going to create a table. I'm setting auto commit as 0. We have to understand what is commit means. Commit means saving the data permanently to a table. Since I made automatically don't save the data to the table, when I start a transaction, when I query or insert some data to the table, after a few seconds, I'm rollbacking the transaction because the user did not pay the amount. So if I run this query overall, you'll be seeing the data shown in the first query as an output. Second time, it won't show the output because the data got rolled back. Are you finding? The second time it is not showing the output because the data got rolled back. Rolled back means what? I'm going to revert the transaction. But I will not revert the transaction immediately. I'll do that slowly. If you do this, you are finding the data is loaded into the table. You're finding the data is loaded into the table. I will do the rollback activity of this data. Then you are finding what? The data is lost from the table. After rollback, or if I don't do rollback, if I do commit means what? Save. Like you open a small notepad, type something, you save without closing. That is rollback. That notepad will be kept for a time being. That is what I was mentioning. This is the transaction control language. What is commit? What is rollback? What is start transaction? This is a transaction control language. So the book my show will start a transaction. It will not automatically commit. The commit one means it will automatically save. Automatically it will book the ticket for the user. No. The transaction is started by the user by opening the web application, the book my show application. He booked a ticket. He chosen a ticket, and it is not visible for others. I mean, it will be visible for others. It will say, hey, the others are going to see only the excluded ticket of this. They will reduce this ticket and all from the actual base table. The actual ticket table, they will reduce this ticket out. They will show only A1, A2, A3 and all as booked for other people who is seeing the same application. But how long? Until this guy pay the amount in another 1 minute, it will be kept in suspense. It will be kept in a temporary stage. Whether it may be rolled back or committed. If it is committed, I can able to see the data. If it is rolled back, I can't able to see the data. That is the core concept behind this. With me, I mean, you have the data now available. Now the user is going to decide, hey, I wanted to revert my transaction. I am not booking the ticket now. Or he is booking the ticket now. He's paying the payment. Now the payment is paid. I am able to see the data. But what he is doing, another ticket, one more person is booking. One more person is doing a booking of one more ticket. Selecting the table. We have two transactions made in the table. But the second ticket is in suspense. It is not fixed. The user, the second ticket booking person, the B1, B2 row person, is rollbacking his transaction. He is not making the payment in his app. So the second transaction will be rolled back. Now we can see only one row in the table. What are the first person who paid the amount can be eligible to see the movie. The second person could not see the movie because it got rolled back because he did not pay the amount in the given time. With me? This is called transaction control language. Clear?
Yes, sir.
Clear? You guys can try this out also since I covered this. Not so easy, guys. This is a tricky thing to understand. I agree. But I just made you understand this to a basic extent of what you can feel convenient. Okay, try this out. What is this? Set commit 0. These concepts and all, don't worry. That and all are some settings, right, in the environment. But try running these commands, see the table output and all. You'll get some idea about it. Don't worry on this. Okay. Okay, guys, just try this out. I'll be uploading all this in our drive. Any other questions?
So Irfan, if it's auto committed, like can we still roll back? Possible?
Definitely not.
Okay.
Definitely not. Commit means it's fixed. How we can roll back then? We have to delete. We can do only a DML operation to roll back. We have to say the first customer ID got committed, right? Even though I give rollback, it is not rolled back because I committed it already. But no, I don't want this customer to watch this movie. Then I'll do what? Delete from table name, right? Where the ID equal to 1. I delete the data. Now I go and see the data from the table, it won't show.
So these auto
Until I
commits and
commit. Okay,
rollbacks are controlled in the code. Is that the case?
I'm sorry, what is it?
These auto commit and rollback are
Obviously,
controlled
yes.
from the code.
Yes. Obviously. If the customer is not making the transaction successful, I'll have a condition. If the payment is not made, then roll back. If payment is made, commit. I'll put an if condition. If payment is completed, commit. Else, roll back. That's it. I'll put it in my code. Clear?
Yeah.
Okay. Yeah. A database table can accommodate a number of tables. We can have a number of tables, and tables can have a number of rows and columns. Is my understanding is correct? No, we have limitations. A number of tables can be accommodated, depends upon the size of the database, size of our database server. But the volume that is stored in the database table, the number of columns that you have stored in the database table is restricted, depends upon the type of databases. If you want to have an unrestricted database table size, then you have to go to big data platform only. In the database platform, it is restricted, Mohan Raj. Okay. In case if you execute DDL statement after DML statement, in the same session, it will be auto commit. See, basically, DDL statement does not have the concept of auto commit or non-auto commit and all. DDLs will be automatically committed. Automatically, the commit will be run as a part of a query, even though you run or not. If I do rollback even now, I don't lose my BMS2 table, BMS1 table. BMS1 table will be always exist. Though I did not wrote what the commit, though I did not mention commit, the BMS table is still available in the environment. The transaction control is only applicable for DML. So what is the difference between DDL and DML? We still have to learn in more detail, but it is applicable only for DML, not for DDL. Okay, Muthu? If you create a table, drop a table, it is done. Whether you roll back, you can't able to roll back. So I dropped this table unknowingly. Can I roll back to get the table back? No, that is not possible. I can't see this table available for me. It is dropped. It is once for all, it is dropped, it is dropped. You can see still, I'm seeing an error. Sorry, there is no table present. BMS1 is lost permanently. Though you did roll back, it won't come back. But the data loaded in the table can be rolled back. If I delete the data in the table unknowingly, I can roll back to get it back. I can commit to permanently delete the data. Like this and all, we have options. Okay, the transaction control language we can use, but mainly in the database environments we use. Not in our big data platform at all. We use this commit and rollback. We don't use this. Okay, that's the reason I'm least bothering about this. Okay, guys. Any questions? Any more questions? Database is very interesting, guys. Actually, if you spend some time on it, you can say like, hey, I got some concrete understanding of some tool means that could be a database. Very interesting component, and it will help you survive and shine and sustain in IT forever if you have a good understanding of it means. Because data understanding is not so direct. You need to have lot of things care about, but see this semantics and all whatever I'm speaking, right? I learned it 20 years ago. That strong foundation, if you put, you could not forget about it. The core, if you don't, I mean, if you remember right, you can able to apply that throughout your lifetime, once for all learning. Because I did this commit at least 12-15 years before. After that, today only I'm writing this term called commit. My hand is typing this commit after 12 years, 13 years. You don't trust me, right? That is how. So this and all we use very rarely. Okay. In this query, where is the condition to say wait for committing? That we have to write as an application, right, Suresh? You are asking me to develop a book my show application in 1 minute, 5 minutes? No, right? Book my show is a very big application. They have lot of functions, programs, and all written in the background to handle all these transactions. If you do a rollback, the data will be rolled back. That is what I'm telling. But how to run in 2 minutes and roll back and all, that is an application development. We have to do it with the help of some Python or Angular or Node or some software, some front-end application. We have to write the logics and that to handle. So we have to capture the session time. We have to capture the payment information. Everything we have to capture and do it as an application. That we can't do here. Maybe we will do such kind of applications in Python. Later we do some sort of application in Python subsequently. Okay, don't worry on that. Don't try to see entire thing. Just take some portion and show particularly. Okay, fine. Anything else, guys? Okay. Otherwise, thanks for attending the session today, guys. Tomorrow morning, weekday people will meet. Sorry, weekend people will meet. Okay, Monday morning I'll meet the weekday people. Thank you all, guys. Thank you all for your time and effort. Keep going. Okay. And try to go through what I have given you guys in the drive. I'll upload right away. Okay. Thank you guys for all your words and keep continuing. Right. Thank you all. Bye, guys.